Hey there, and welcome to this exciting React.Js course. Get ready to dive into the world of modern web development, where you'll be building practical skills to create dynamic and engaging user interfaces using React. This course is packed with hands-on coding exercises designed to help you really master essential concepts like components, state management, and APIs. And don't forget, I've included a link to the GitHub repository where you'll find all the code you'll need. And trust me, you'll want to stick around until the end for a final project that showcases everything you've learned, also available in the GitHub repository. So, let's get started. In the realm of technology, web development is like magic. It transforms mere ideas into interactive, functional applications. Today, we're kicking off an exciting journey to delve into the foundational concepts of web development. We'll focus on two important areas: front-end and back-end development. Now, the front end is all about what users see and interact with: aesthetics, layout, and responsiveness. Think of it like the storefront of a shop, attracting customers. Meanwhile, the back end powers everything behind the scenes, handling data management and server interactions. These two sides work together seamlessly to create an engaging user experience. But to build these applications, we need to understand the essential technologies involved. HTML, CSS, and JavaScript are the holy trinity of front-end development. HTML structures the content, CSS styles it, and JavaScript brings it to life with interactivity. Whoa! On the back end, we rely on languages like Python, Ruby, or Node.js to handle server-side logic. Plus, we have databases like MySQL or MongoDB, where all our data is safely stored. Now, speaking of frameworks, they're like cheat codes for developers. They simplify the process and give us powerful, ready-to-use tools to speed up development. Frameworks like React or Angular for front-end and Express or Django for back-end help us build applications faster and with more stability. So, as we journey through this world of web development, just remember the balance between front-end and back-end, the tech stack, and the frameworks available. These are the keys to creating amazing web applications. All right, let's dive deeper into each aspect as we go along. Now, let's dive into how we can create a simple web page structure using HTML. At the beginning of our code, we start with !document HTML. This line, it tells the browser, hey, I'm working with HTML5 here. Next up, we specify the language of the document using the HTML lang equals n tag, which is super important for accessibility. Now, moving on to the head section, we set the character encoding to UTF-8. This ensures that our characters are displayed correctly. And we include the viewport meta tag to make sure our page looks good on all devices. All right, now let's give our page a title inside the title tag. This title will show up in the Browser tab. Here comes the exciting part. We jump into the body, which is where all the visible content lives. We'll start with the header, and inside it, we create an H1 tag. This serves as the main title of our page, welcoming visitors on entry. Beneath that, we have the main section, where the primary content area resides. Here, we can toss in a brief description using a P tag. Finally, we wrap things up with a footer to showcase copyright information. This simple structure is fundamental for building web pages, making sure everything is organized and easily readable. So, there you have it, a clear and concise blueprint for setting up your HTML page. Next, we will write the CSS code that styles our HTML web page, enhancing its visual appeal and user experience. In the style sheet, we kick things off by applying styles to the body. Here, we're going to use a clean and modern font, Arial, along with a light background color of F4F4F. This combination creates a soft canvas for our content, ensuring that your text is not just readable, but also inviting. We'll also set the margin and padding properties to give the page some breathing room and prevent any clutter at the edges. Now, let's move on to the header. We assign it a dark background color, N35424A, which contrasts beautifully with white text. This not only makes the header pop, but also catches the user's attention instantly. Plus, centering the text provides a clear and organized introduction to the content of the page. Now, for the main section, we're going to add some margin to separate it from the header and the footer. This little tweak enhances the overall layout structure even further. Lastly, we style our footer to be centered with a margin at the top, ensuring consistency throughout the page. By applying these simple yet effective style rules, we're significantly improving the overall aesthetics and readability of our web application. Now, let's explore how we can add interactivity to our web pages. To accomplish this, we're going to create a function named showAlert that triggers an alert message when it's called. This function is pretty straightforward. It contains just a single line of code that displays a message saying "button was clicked." Next, we need to ensure that our function is called at the right moment. For that, we'll use the document.getElementById method to select the button element on our web page with the ID myButton. Once we have that button reference, we'll assign the showAlert function to the button's onClick event. So, every time a user clicks on the button, JavaScript will execute the showAlert function, making the alert pop up on the screen. This simple yet effective mechanism showcases JavaScript's ability to enhance user engagement, allowing for a more dynamic experience in our web applications without needing to reload the page. By incorporating such interactions, we're really moving toward a more sophisticated and user-friendly interface. Now, having established a basic understanding of HTML, CSS, and JavaScript, it's crucial to differentiate between front-end and back-end development. Now, front-end development, often referred to as the client side, encompasses all activities related to the visual elements that users interact with directly. This includes everything from layout and design to user interface and experience. On the other hand, back-end development, or what we call the server side, involves the underlying logic and functionality that power the application. Think of it this way. Back-end development includes database interactions, server configurations, and application logic processing. Let's make an analogy. Imagine entering a restaurant. The front end is the dining area, where you see the decor, the menus, and fellow diners enjoying their meals, while the back end is like the kitchen, where the actual food is prepared based on orders. This distinction is fundamental, as it helps you understand how the two sides work together to create a seamless user experience. Now, let's implement a simple component using React, a powerful library for building user interfaces. The component we're going to create is called Greeting. This function-based component utilizes JavaScript's component architecture, allowing us to write reusable pieces of UI code. Inside the component, we use the return statement to return our desired JSX, which, just to clarify, resembles HTML but exists within JavaScript. In this case, we're returning a div element that contains a header with the text, "Hello, welcome to my website." This demonstrates React's capability to create dynamic UI elements. The component can be easily integrated into larger applications, promoting code reuse and maintainability. After defining the greeting component, we will export it as the default export of this module. This is essential when we want to import this component in other parts of our application, allowing us to break down our UI into smaller, manageable pieces. Using React's component-based architecture not only streamlines development, but also enhances collaboration among developers, as components can be shared and reused across different projects. Now, let's implement a basic web server using Node.js and the Express framework, which really simplifies server-side development. First things first, we need to grab the Express package and create an instance of it. That's our way to configure our server. Now, let's set a constant for the port number, which is where our server will listen for incoming requests. Next up, we define a route with the app.get method. What this does is specify that when a user hits the root URL, or, the slash path, our server responds with the text, "Hello World." Pretty cool, right? This simple interaction shows us just how efficiently Express handles HTTP requests and serves responses. Finally, we use app.listen to get our server active on that port we designated earlier. This function takes a callback that logs a message telling us that the server is up and running, along with where we can find it. With this setup, developers can quickly get a web server rolling. It's a solid foundation for building more complex server-side applications that can handle various endpoints and functionalities. As we venture deeper into web development, understanding the architecture of web applications is becoming essential. Most modern web applications follow a three-tier architecture: the presentation tier, the application tier, and the database tier. Now, let's break this down a bit. The presentation tier is the front end where all the magic happens when users interact with your application. It's what they see and engage with. Then we have the application tier. That's the brain of the operation. It handles the logic and processes all the actions. And finally, there's the database tier, which is all about storing and retrieving data. So let's say we're building an application like a bookstore. In this case, the presentation tier would show all the lovely books on a web page, beautifully displayed using HTML and styled with CSS. Picture it, a clean, inviting interface. Now, over on the application tier, it's handling the behind-the-scenes work, like searching for books, adding them to a shopping cart, and even processing those orders, keeping everything running smoothly. And lastly, we have our database tier, where all the important details are stored. Think about the titles, authors, prices, and how many copies you have in stock. It's like the backbone of your bookstore, quietly ensuring everything is in order while users just enjoy browsing and shopping. See how these tiers all work together? It's a fascinating dance of technology that makes our web experiences possible. Now that we've explored the benefits of ES6, let's dive into how we can implement a simple addition operation using modern JavaScript features. We begin by defining a constant named add, which we assign an arrow function to. This function takes two parameters, a and b, and simply returns their sum. Arrow functions not only provide a more concise syntax compared to traditional function expressions, but they also lexically bind the this context, which makes working with functions in certain scenarios much simpler. Next, we declare a variable called result using the let keyword. This allows for block scoping. It's a nice enhancement over the traditional var declaration. By invoking the add function and passing in the arguments 5 and 3, we effectively compute the sum. Now, the result is then logged to the console so we can visually verify that the function is performing as intended, outputting the value 8. Whoa! This example illustrates how ES6 introduces syntax and functionality that really enhances both the readability and efficiency of our JavaScript code, making it so much easier to write and maintain modern web applications. Next, we will explore the concept of destructuring in JavaScript, which provides a succinct way to extract values from objects. In our example, we define a book object containing two properties: title and author. Now, using destructuring, we can unpack these properties directly into distinct variables, title and author, allowing us quick access to their values. This not only enhances code readability, but also streamlines variable management, especially when dealing with multiple properties. Now, let's move on to the spread operator, a powerful feature that enables us to expand or clone arrays or objects effortlessly. In our scenario, we start with an initial array, original array, containing the values 1, 2, and 3. By utilizing the spread operator, we can create a new array, which includes all elements of original array, along with additional values, 4 and 5. This technique is invaluable for scenarios like managing application state in frameworks such as React, where immutability and efficient updates are crucial for optimal performance. As we progress, it's essential to consider how we keep our applications scalable and maintainable. Leveraging powerful frameworks and understanding modern JavaScript features are key components in achieving this goal. With the right tools, web development transforms from a daunting task into an exciting adventure filled with creative possibilities. So, as we conclude this introduction to web development concepts, remember, the web is a canvas, and you have the brush. With practice, patience, and an adventurous spirit, you can create web applications that not only function seamlessly, but also inspire and engage users to return again and again. Thank you for joining me on this journey today. Stay curious, keep coding, and who knows, perhaps the next innovative web app will have your name on it. JavaScript has gone through quite a journey, right? With ES6 stepping in as a true game changer, it's really transformed the way we write code, especially in the realm of React.Js. In this lesson, we're going to dive deep into some modern JavaScript features that supercharge our React applications, blending functionality with sleek and efficient coding practices. So far, we've laid the groundwork by learning the foundational concepts of web development, focusing on those three core technologies: HTML for structure, CSS for design, and of course, JavaScript for interactivity. We've also touched upon the differences between front-end and back-end development, plus the handy tools and frameworks that help us whip up web applications. Now, let's not forget those awesome ES6 features that elevate JavaScript to a new level. We've explored things like destructuring and the spread operator, which totally improve code efficiency. And we've highlighted how crucial scalability and maintainability are when we're building those web apps. Now, let's get right into those ES6 features and discover how they integrate seamlessly into React.Js. This means our code isn't just cleaner, it's also more powerful. And who wouldn't want that? Now, let's take a look at how we can create a simple counter component using React and arrow functions. In this example, we're working with a counter class that extends React.component, which makes it a React component. Inside this class, we initialize the state with a count property set to 0. All right, next up, we'll define an increment method as an arrow function. Now, this is really important because it automatically binds the this context to our current instance of the counter class. This means that when we call this.state, it accurately refers to our component instance, making sure that state updates are handled properly, which helps us avoid the common pitfalls that arise with traditional function declarations. The increment method updates the count using the functional form of state set, giving us a safe way to access the current state. Now, let's move to the render method, where we'll return a straightforward JSX structure. This includes a heading that displays our count and a button that triggers the increment function. This setup allows our users to interact with the button, reflecting real-time updates to the count shown on the screen. By utilizing arrow functions, we ensure a cleaner and more reliable component structure, enhancing readability and keeping our state management intact. Now, let's dive into implementing a functional component that greets the user by name. In our example, we'll define a user greeting component that takes a user object as a prop. So, within the return statement, we'll use a template literal to craft our greeting message dynamically. This approach lets us embed the user's name directly into the string, which honestly makes it a lot cleaner and easier to read compared to the traditional string concatenation methods. By using those handy backticks, we have the ability to interpolate the user.name expression, ensuring that the greeting feels personalized for each user. The result? A concise component that not only boosts readability, but also helps minimize the chance of errors that often crop up with older string concatenation techniques. This method showcases the amazing power of ES6 features in streamlining our code and significantly enhancing our overall React application structure. By integrating template literals, we simplify how we represent dynamic content in our JSX, making our code more elegant and efficient. So, let's see how easy it really is to create a user-friendly greeting system. Now, let's dive into how we can streamline the extraction of properties from an object using destructuring within a functional React component. In this example, we're defining a user card component that takes in a user object as a prop. By destructuring the user object right in the component's parameters, we can pull out the name, age, and email attributes at once. This method makes our code cleaner and a lot more readable since we're avoiding the need to repeatedly reference the props object. Now, as we implement the user card, we can directly utilize those destructured variables within the JSX that the component returns. This really cuts down on boilerplate code and makes it clear at a glance which properties we are using from the user object. Each of these properties displays nicely within a straightforward layout of HTML elements. So you see, destructuring does more than just write concise code. It also boosts maintainability because it minimizes potential errors and clarifies our intentions right at the top of our component definition. Now, let's take a look at how we can manage state updates effectively using the spread operator in a React component. In this example, we're going to define a to-do list component that maintains a list of to-dos in its state, which we'll initialize as an empty array. So we're going to use an arrow function for our add-to-do method, and this approach allows us to easily set the state based on the previous value. Inside this method, we call this.setState, and we pass a function that takes the previous state as an argument. Now, here's the crucial part, updating the to-dos array. Using the spread operator, we create a new array that combines the existing to-dos with the new to-do that we want to add. This approach helps us avoid modifying the original state directly, which is super important because it aligns with React's principles of immutability. As we render our list of to-dos in the render method, we map over the to-dos array, creating a list item for each to-do using the index as a unique key. This not only keeps our code neat and tidy, but it also enhances the maintainability and scalability of our application, allowing for efficient management of state updates. Wouldn't you agree that keeping our code clean and organized makes our lives a whole lot easier? Next, we will write a simple functional component using default parameters, which is a powerful feature that helps improve the reliability of our code. It provides fallback values for function arguments, ensuring that everything runs smoothly. In our greeting component, we define the name prop with a default value of guest. So, what this means is, if the component is rendered without a name prop, it will automatically use guest instead of returning undefined. This approach not only simplifies our code, eliminating the need for those extra checks to handle undefined values, but also enhances the overall user experience. Imagine it. Every user is welcomed appropriately, even if they don't provide their name. Within the return statement, we utilize JSX to display a greeting message that incorporates the name value. This means it will dynamically show welcome guest or welcome name, depending on the prop passed. And by implementing default parameters, we've made our component more robust and user-friendly. This showcases how even small changes can significantly affect how components behave and how users interact with them. So, this approach really exemplifies clean coding practice. It aligns with modern JavaScript standards and improves code maintainability. Now, let's implement modular code using ES6 modules, which really enhances code organization and reusability. In our example, we begin by creating a user component in a separate file named user.js. This component, it's designed to receive a name prop and display it within an h2 element. Kind of a clean and focused piece of functionality, right? Next, we shift our attention to the main application file, app.js, where we'll import the user component. By utilizing the import statement, we can bring in the user component from its module path. This promotes this fantastic separation of concerns in our code base. So, once we've imported, we can utilize the user component within the app component's render method, passing in a name, let's say John Doe, as a prop. This approach allows us to maintain a cleaner code structure where each component is contained within its own file. It makes our application easier to manage and scale. Plus, the modular design not only enhances reusability, but also helps in maintaining and updating the code effectively as the project evolves. Now, let's take a look at how we can implement asynchronous operations in a React component using the async/await syntax. In the user profile class, we define a state variable called user, which is initialized to null. This state holds the user data we will fetch from an API. As soon as the component mounts, the compo_did_mount lifecycle method triggers an asynchronous function. Within this function, we use the await keyword to pause execution until the fetch request is complete, which allows for a cleaner handling of promises. Once the data is fetched, we parse the JSON response and update the state with this user data using setState. Error handling is also integrated, where any issues with the fetch operation will be caught and logged. This streamlined approach not only makes our code more readable, but also allows us to write asynchronous code as if it were synchronous, significantly reducing the cognitive load. In the render method, we check if the user state is still null, displaying a loading message while we wait for the data, and finally rendering the user's name when the data is available. Thoughtful pause. This showcases how async await simplifies asynchronous programming in React. Now, let's take a look at how we can implement classes and inheritance to create a more structured approach to our components in React. In our code, we're starting off with a base class named Animal, which serves as the foundation for various types of animals. The Animal class includes a constructor that initializes a property called Name. Plus, it has a speak method that returns a general sound associated with the animal. Next, we create a dog class that extends the animal class. This means that dog inherits all the properties and methods from animal, allowing us to reuse that logic without rewriting it. Isn't that neat? So inside the dog class, we override the speak method to specify that our dog, barks instead of making some generic noise. This really showcases how inheritance allows us to create specialized behavior for different types of animals. Finally, we instantiate a new dog object named Rover and call it speak method. This demonstrates how we can create instances of our classes that leverage shared functionality while still allowing for specific behaviors tailored to each animal. By organizing our code like this, we enhance reusability and maintainability, key principles that help us in building scalable React applications. In conclusion, modern JavaScript features introduced with ES6 have really transformed the way we write React applications. I mean, just think about it. Arrow functions, template literals, the spread operator, and async await. Each of these features brings its own unique advantages, making our code clearer, more efficient, and definitely easier to maintain. As we deepen our understanding of these tools, we'll notice that our applications not only become more powerful, but also remain readable and manageable. And embracing these features doesn't just make us better developers, it lets us create cutting-edge applications that truly push the boundaries of what's possible on the web. So, keep practicing these awesome features and don't hesitate to weave them into your React projects. Happy coding! Welcome, everyone! Today, we're diving into one of the most powerful features of JavaScript, advanced array methods. If you've ever wanted to master how to manipulate arrays like a true wizard, you're in the right place. So far, we've learned about the evolution of JavaScript, particularly the impact of ES6 on coding practices within React applications. We explored key features like arrow functions, template literals, destructuring, the spread operator, default parameters, modules, async await, and class inheritance. All of these tools enhance our code's readability, efficiency, and maintainability. As we continue, we'll apply these features to further elevate our React development skills. Let's jump right in and unlock the full power of arrays together. Now, let's dive into how we can use the reduce method to sum up the numbers in an array. We'll kick things off by defining a constant array called numbers, which holds a simple sequence of integers from 1 to 5. Next, we apply the reduce method to this array. Now, the reduce function takes two parameters in its callback: the accumulator, which is our running total, and the current value, which represents the current element being processed in the array. So, here, we initialize the accumulator to 0, setting the stage to start our summation from 0. As reduce goes through each number in the array, it adds that current number to the accumulator. By the time we've processed all the elements, the accumulator holds the final sum, which in this case is logged to the console. And guess what? The output will be 15, showcasing just how effective and concise the reduce method is for aggregating values in an array. It's a fantastic way to turn complex operations into something simpler and much more readable in our code. Now, let's see how we can implement reduce to transform an array of user objects into a more accessible format. We start with this array of user objects, right? Each one, has an ID and a name. The goal here is to create an object where those user IDs serve as keys and their names are the corresponding values. This way, we can quickly access what we need. In our code, we call the reduce method on the users array, passing in a callback function and an empty object as the initial value for our accumulator. Now, the callback function processes each user object. We extract the ID and name, and for each user in the array, we assign their name to the accumulator object using the user's ID as the key. After we've iterated through all the users, we end up with a single object that maps user IDs to their names. This structure really makes lookups efficient. Rather than scanning the entire array to find a name by ID, we can now directly access it using the object's key. Finally, we log that resulting object to the console. It's a neat way to see how this transformation enhances our coding efficiency and usability. Next, we will explore the filter method, a powerful tool for creating new arrays based on specific criteria. This method lets us process each element of an array and include only those that satisfy our conditions. So, in the code we've written, we start by applying filter to our given array of numbers. We're checking each number to see if it's divisible by 2, which means we're identifying the even numbers. The expression num arrow num mod 2 equals 0 acts as the callback function for filter. It evaluates each num from our original array, returning true for even numbers and false for the odd ones. Consequently, the filter method builds a new array called even numbers, which holds only the values that meet this condition. Finally, we output this new array to the console to see the result. 2, 4, 6, 8, 10. This practical example really demonstrates how effective the filter method can be in extracting relevant data from a larger dataset. By using filter, we can refine our arrays, making them easier to work with in later operations or to present to the user. Now, let's explore how we can effectively filter out active users from an array of user objects. So, in our example, we have this array called users, and each user object within it includes an ID, name, and an active status. To pinpoint those active users, we can make use of the filter method, which allows us to pass in a callback function that checks the active property of each user object. What this does is it creates a new array containing only the users whose active property is true. Simple enough, right? Now, to streamline those results even more, we can follow up with the map method. Here, we'll again pass a callback function, but this time, we're focused on extracting just the name property from each active user object. The end result is a tidy array of names that showcases only those users who are currently active. Finally, let's log that active usernames array to the console. This displays a neat list of names and demonstrates how effectively these array methods can be combined to manipulate and transform data in a clear, maintainable format. This really highlights the power of chaining methods in JavaScript for handling sophisticated data tasks. Next, we'll explore the versatile map method. This method allows us to transform each element in an array and create a new array populated with the results. Let's take a look at how we can implement this in our code. So, first off, we define an array called numbers that holds the integers from 1 to 5. Now, with the map method, we take it a step further and apply a function that doubles each number in this array. We can do this using the arrow function syntax, expressing it as num times 2. Pretty neat, right? When we run this, the map method processes each item in the numbers array, applying that doubling function and creating a shiny new array called doubled. The new array is then logged to the console, displaying the output as 2, 4, 6, 8, 10. This really highlights how map not only keeps our code clean, but also boosts readability and efficiency. We're skipping all that verbose stuff, like those bulky for loops. By embracing such elegant methods, we can manipulate data in a concise and graceful way. Now, let's dive into how we can create a new array of user objects that only includes the name and email properties from our original array. In this example, we're starting with a constant array called users, which holds several user objects, each containing an ID, name, and email. To pull out just the bits we need, we're going to use the map method. This little gem lets us iterate over each user object in the users array, transforming each one into a simpler object that consists just of name and email. By utilizing destructuring in our callback function, we can directly tap into these properties, which really helps streamline our code and makes it much easier to read. As a result, we'll generate a new array named user emails, where each item is an object that contains only the name and email for each user. This tidy transformation not only cleans up our structure, but also trims away unnecessary info, making it a lot simpler to work with as we move forward. And when we log this new array, you'll see organized user details popping up, beautifully showcasing a practical application of the map method in array manipulation. Now, let's take a look at how the sum method works in JavaScript. In this example, we define an array called numbers that contains several integers. The goal here is to determine if there's at least one odd number present in this array. To achieve this, we utilize the sum method, which, as the name suggests, executes a provided function on each element in the array until it finds one that returns true. In our case, the function we provide checks if a number is odd by using the modulus operator, specifically to see if the number divided by 2 leaves a remainder of 1. So, if sum finds any odd number at all, it will immediately return true. Otherwise, it returns false. Now, when we call console.log has odd, we get the output true, since the numbers 1, 3, and 5 in our array are indeed odd. This method is particularly handy for quickly testing conditions across an array without having to iterate through every single element unnecessarily. It makes it an efficient choice for many scenarios in your JavaScript programming. Now, let's dive into how we can check if all the numbers in an array are even using the every method. So, first, we'll define an array called numbers. And for this example, it contains a series of even integers, 2, 4, 6, and 8. Next, we'll use the every method, which goes through each element of the array and tests it against a condition that we set in a callback function. Here, our condition is simple. We're checking if each number is divisible by 2, which lets us know whether it's even. Now, here's the interesting part. The every method will return true if all numbers meet this condition, and it'll give us false if even one number doesn't make the cut. In this case, since all our elements, 2, 4, 6, and 8, are indeed even, the method takes a look at the entire array and correctly logs true to the console. This really highlights the power of the every method. It helps us validate conditions across our arrays in a way that's not only concise, but also super readable, which ultimately leads to cleaner and more maintainable code. Next, let's explore an example to see how the find method functions in JavaScript. This method is super handy for retrieving an object from an array based on a specific condition. It's like having a targeted search tool at your disposal. So picture this. We have an array full of user objects. Each one comes packed with details, such as ID, name, and age. Now, when we invoke find on this array, we can pass in a callback function that checks a user's age. In our case, we're looking to find the user who is 30 years old. So what happens is the find method goes through the array, checking each user object one by one, executing our callback function as it goes, until it finds a match. Once it locates that user, it returns the object associated with them. But if it doesn't find a match, well, it simply returns undefined, indicating that no user met our search criteria. Now, to see this in action, we can use console.log to output the result. That way, we can easily verify that we successfully retrieved the user we were looking for. This whole process demonstrates just how find streamlines the retrieval of objects from arrays, making our code not only more efficient, but also far more readable. Now, let's take a look at the sort method, which is crucial for ordering elements in an array. Continuing, in this example, we have an array of numbers that we want to sort in ascending order. Now, while the sort method can seem straightforward, it's really important to remember that it sorts elements based on their string values by default. This can lead to, unexpected results when you're dealing with numbers. So, to make sure the numbers are sorted correctly, we provide a comparison function to sort. This function takes two arguments, a and b, representing the elements being compared. By subtracting b from a, we establish the ordering criteria. If the result is negative, a comes before b, and if it's positive, well, then b comes before a. This approach guarantees that the numbers are sorted numerically, not as strings. So, when we run the code, we start with an unsorted array. 10, 1, 5, 2, and after applying sort, we get the correctly ordered output 1, 2, 5, 10. This demonstrates how sort can be effectively used to manipulate data, enhancing our array handling in JavaScript. Now that we've gone over the advanced array methods, you should feel much more equipped to tackle data manipulation in JavaScript. These methods, Reduce, filter, map, sum, every, find, and sort are more than just useful. They're essential tools in your programming toolkit, especially when you're working with React applications where effective data management is key. So, as you set out on your journey into advanced JavaScript, remember that these methods will not only streamline your code, but also empower you to write cleaner, more efficient, and more maintainable applications. Keep practicing, and you'll be well on your way to mastering array manipulation in JavaScript. Happy coding! In this lesson, we're diving into the fundamentals of web development. We'll explore the essential building blocks that enable us to create interactive web applications. So far, we've learned about advanced array methods in JavaScript, things like reduce function, filter, and map function. These methods are fantastic for efficient data manipulation, and they really help enhance code readability and maintainability, especially when we're working in React applications. Now, let's transition to the core technologies of web development: HTML, CSS, and JavaScript. Web development is primarily divided into two major parts, the front end and the back end. The front end is what users see and interact with in their web browsers, while the back end is the server-side functionality that processes requests and manages the database. Understanding how these layers interact is crucial for creating a fully functional web application. Now, let's take a look at a simple HTML structure that forms the foundation of our web page. The very first line specifies the document type, letting the browser know that this is an HTML5 document. Then, we dive into the HTML tag, which kicks off our HTML document, and we make sure to specify the language, setting the lang attribute to EN for English. Now, within the head section, we define the character set and viewport settings. These are crucial for ensuring our website displays beautifully across various devices. The title element is particularly important. It gives our page a title that shows up in the Browser tab. All right, moving into the body, this is where we start structuring our web page using semantic elements. The header houses an H1 tag that serves as the main heading. It's like a welcoming sign for our visitors. Now, in the main section, we include a paragraph that introduces the content of the page. And here, we can't forget the button element. It's key because it allows users to interact with the web page. Finally, our footer wraps everything up nicely with copyright information. This structure not only organizes our content, but it also enhances accessibility and SEO, making it crystal clear to both users and search engines what the page is all about. Next, we will write the following CSS to enhance the appearance of our HTML structure, which is essential for creating a visually appealing web application. First, let's select the body element and apply a font family of Arial. Now, Arial is widely used because of its readability, making it a solid choice for our text. We're also going to set the margin and padding to 0. This really helps, right? It ensures that our elements don't have any unnecessary spacing around them, which creates a clean and organized layout. The background color we'll set to a light gray. This gives us a neutral base that allows other elements to stand out beautifully. Now, let's move on to styling the header. We'll give it a vibrant green background and white text. The padding here creates space around the text, making it visually appealing. And center-aligned text? Oh, that draws the user's attention right to the main title, which is just what we want. Moving on to the button element, we will ensure it's user-friendly by applying a blue background color with, you guessed it, white text. This color combo is not only attractive, but also easy to read. The button's padding, border radius, and margin, they all add to its appealing look, making it easily clickable and inviting for interaction. So, to wrap up, this CSS code effectively enhances our HTML structure, setting the stage for a more engaging user experience. Now, let's dive into how we can add interactivity to our button using JavaScript. In this code, we utilize the getElementById method to select the button with the ID "Click Me." This method is key because it helps us target specific elements within our HTML directly, making it a lot easier to manipulate them. Okay, once we've done that, we need to attach an event listener to the button. So what's an event listener? Well, it's a function that waits for a specific event to happen, like a click. When that button is clicked, the function we define in the listener gets triggered, executing the code that follows right away. In our example, this function shows an alert box that says "Button was clicked." This is a great demonstration of how JavaScript helps us create a responsive user experience. It allows our application to react when users interact with different elements on the page. Understanding this fundamental concept really opens the door to more complex functionalities, like form validations or fetching data from an API, which makes our applications not just functional, but also engaging. Let's briefly chat about libraries and frameworks. Now, while it's definitely possible to build a complete application using just HTML, CSS, and JavaScript, tackling complex projects can get a bit unwieldy. That's where libraries and frameworks really shine. Think of libraries, like jQuery, as your helpful toolbox, providing pre-built functions that simplify common tasks. On the other hand, frameworks such as React.Js, Angular, and Vue.js give you specific structures and conventions for constructing your applications. So, for example, we'll focus on React.js later in this series. Now, React uses a component-based architecture, which is all about managing the user interface, or UI, efficiently. With this approach, you can build encapsulated components that handle their own state, and then compose them together to create more complex user interfaces. This isn't just a neat trick. It significantly improves your code's reusability and organization. So stay tuned as we dive deeper into how this all works. Now, it's important to understand the architecture of web applications, so let's dive in. The three-tier architecture model is widely used in web development, and it consists of three main layers. First up, we've got the presentation layer. This is essentially the front end, where all the visual magic happens, and users interact with the application using HTML and CSS. Next, we move to the application layer. This is where the business logic lives, typically powered by JavaScript, acting like a bridge between the user and the data. Finally, we have the data layer. Here, this layer usually consists of a database that securely stores all the information for the application. Now, understanding these layers is crucial, as it helps you develop scalable applications and tackles problem-solving effectively in web development. So, keep these components in mind as they form the backbone of any web application you create. To summarize what we covered today, we dived into the essential concepts of web development, exploring HTML for structure, CSS for styling, and JavaScript for interactivity. We also discussed the significance of libraries and frameworks, along with the architecture behind web applications. In our next lesson, we're going to take a deeper look at JavaScript, particularly with modern concepts that are crucial for working with React.Js. Just remember, mastering these basics really lays a solid foundation for your web development journey. So stay tuned for more exciting content.
JavaScript has had many versions over the years, and ES6 is one of the significant milestones in the evolution of the language. In this lesson, we will explore modern JavaScript features introduced in ES6 and beyond, which have revolutionized how we write JavaScript today. So far, we learned about the basics of web development, including the importance of HTML for structure, CSS for styling, and JavaScript for functionality. We discussed the interaction between the front end and back end, and highlighted the significance of understanding libraries and frameworks for managing complex projects. Additionally, we introduced the three-tier architecture model relevant to web applications. Now we will dive into the powerful modern features of JavaScript that make coding more efficient and enjoyable. Now let's see how we can implement variable declarations using let and const. In this code, we define a function called demo variables where we initialize a block scope variable named count using the let keyword. This variable can be incremented as we loop through a specified number of iterations. The second variable, maxCount, is defined using const, which makes it a constant value that cannot be reassigned, ensuring its integrity throughout the function. Within the for loop, we utilize the count variable to track the number of iterations while logging its current value to the console. This practice reinforces how let enables dynamic changes within its block scope, which is particularly useful in loops. An important lesson here is the benefit of using const for values that should remain unchanged, as demonstrated by the commented out line that would throw an error if we tried to reassign maxCount. By adopting these modern variable declaration methods, we can write cleaner, more robust code that avoids common pitfalls associated with the older var keyword. Now let's see how we can implement template literals, a powerful feature introduced in ES6 that simplifies string creation and interpolation. In the first example, we define two constants, name and age, to store a person's name and age. Using template literals, we create a greeting message that seamlessly incorporates these variables without the need for cumbersome concatenation operators. The syntax is straightforward. We wrap the entire string in backticks and embed the variables within placeholders. This approach not only enhances readability, but also minimizes the potential for syntax errors. Next, we will write a multi-line string using template literals, showcasing their flexibility. By leveraging the same backtick syntax, we can create a string that spans multiple lines without needing special characters for line breaks. This feature is particularly useful for formatting longer texts in a more natural and organized manner. By employing these string techniques, we can produce cleaner and more comprehensible code, making our programs easier to maintain and understand. Now let's discuss how we can define functions concisely using arrow functions. The first part of the code illustrates the difference between a traditional function expression and an arrow function. Both functions perform the same task, which is adding two numbers together, but the arrow function is much more succinct and eliminates the use of the function keyword. This makes the code cleaner and easier to read. Next, we will consider the implementation of a timer using a traditional function. When we set up a timer with setInterval, the conventional function does not correctly reference the timer instance, which leads to unexpected behavior where this refers to the global object instead. This issue can cause confusion, especially in larger applications. Now let's implement the same timer functionality using an arrow function within setInterval. This change solves the this binding problem, allowing us to increment the seconds correctly, as now this properly refers to the instance of the timer class. The implementation showcases not just the syntactic benefit of arrow functions, but also their capacity to provide more intuitive behavior in handling the context of this. Now that we have discussed destructuring, let's see how we can implement it in our code. In the first example, we define a student object containing properties such as name, age, and major. Without destructuring, we had to repeatedly access each property using the object reference. This can lead to redundancy and makes our code harder to read. Next, we rewrite the same example using destructuring syntax. Instead of assigning each property one by one, we can extract the values directly from the student object. By utilizing curly braces, we unpack the properties into separate variables named name, age, and major. This approach not only reduces redundancy, but also makes it clear what each variable represents, improving the overall readability of the code. Now let's see how destructuring can also be applied to arrays. In the following example, we have an array of numbers. By using square brackets, we can assign each value in the array to distinct variables in one clean line. This showcases the flexibility of destructuring, which allows for a more concise and understandable way to manage data in our code. Now let's explore the powerful features of the spread and rest operators in JavaScript. The spread operator, denoted by 3 dots, allows us to expand elements of an iterable, such as an array, into another array or function arguments. For instance, we can merge two arrays effortlessly. By using the spread operator, we can combine R1 and R2, resulting in a new array that contains all their elements. This approach is more intuitive than utilizing traditional methods like concat. Next, we will implement object cloning using the spread operator, which simplifies copying an object into a new one. This is especially useful when we want a duplicate of an object without modifying the original. Now let's take a look at the rest operator, which collects all remaining function arguments into an array. By utilizing the rest operator, we can create a function that takes an arbitrary number of arguments. For instance, in our sum function, The rest operator gathers all the provided numbers into an array called numbers, enabling us to perform operations like summing up the values easily. This feature makes our function more versatile and powerful, adapting to various input scenarios efficiently. Next, we will write a simple example to demonstrate how classes work in JavaScript. Here, we define an animal class that serves as a blueprint for creating animal objects. In this class, we have a constructor that takes a name parameter and assigns it to the instance variable this name. This allows us to give each animal a unique name. Additionally, the animal class includes a speak method that outputs a generic message indicating the sound the animal makes. Now let's take a look at how inheritance works by introducing a dog class that extends the animal class. This means that the dog class will inherit properties and methods from the animal class. We override the speak method in the dog class to provide a specific message for dogs, indicating that they bark. This approach demonstrates how subclasses can build upon or modify the behavior of their parent classes, promoting code reuse and clarity. Finally, we create an instance of the dog class named Rex, and when we call its speak method, it will output a message indicating that Rex barks. This encapsulated structure helps in organizing our code effectively and showcases the power of object-oriented programming in JavaScript. Now let's implement a simple module for mathematical operations using ES6 features. We start by creating a file named math.js where we define two functions, add and subtract. Each function takes two parameters, performs the respective arithmetic operation, and returns the result. By using the export keyword, we make these functions available for other modules to import and utilize. This encapsulation of functionality promotes reusability and clarity, as demonstrated in the next step. Next, we will create another file called main.js to make use of our math.js module. In this file, we will import the add and subtract functions using the import statement. This allows us to use these imported functions directly to perform calculations. To illustrate their functionality, we invoke the add function with the arguments 5 and 3, which results in 8, and log the output to the console. Similarly, we call the subtract function with the same arguments, yielding an output of 2. This organized approach to coding through modules enhances the maintainability and scalability of JavaScript applications, especially when working in collaborative environments. Now let's take a look at how we can implement asynchronous operations using promises in JavaScript. The code begins with the creation of a new promise object, which takes a function with two parameters, resolve and reject. Inside this function, we use setTimeout to simulate a delay, mimicking an asynchronous data fetching operation that resolves after 2 seconds. Here, we create a data object to represent the outcome of our operation. If the success property in the data object is true, we call the resolve function with a success message. If not, we trigger the reject function with an error message. Next, we call the fetchData promise. This is where the power of promises truly shines, as we can use the then method to specify what happens when the promise is resolved successfully. In this case, we log the message to the console. Conversely, if the promise is rejected, we handle the error in the catch method, ensuring we capture and log any issues that occur. This structure allows for clean, readable asynchronous code, avoiding the pitfalls of callback hell while providing a clear flow for handling success and error scenarios. Now let's implement asynchronous behavior in our JavaScript code using async_await, a feature introduced in ES8 that simplifies working with promises. First, we define a function called fetchData, which simulates an asynchronous data fetching operation. This function returns a promise that resolves after a simulated delay of 2 seconds, representing a typical scenario where data is retrieved from an API. This snippet effectively demonstrates how asynchronous tasks can be encapsulated in a promise. Next, we create another function called getData, marked with the async keyword, which allows us to use the await operator within its body. This operator pauses the execution of getData until the promise returned by fetchData resolves, ensuring that the result is ready for use before we proceed. Once the data is fetched, we simply log the result to the console. By utilizing async_await, we enhance code readability and streamline error handling, enabling better management of asynchronous workflows. This approach replaces complex promise chains with straightforward synchronous-like code structure that is easier to follow. So there you have it, a deep dive into modern JavaScript features that make coding more effective and enjoyable. We explored variable declarations, template literals, arrow functions, destructuring, and more. Understanding these features is crucial as they lay the foundation for working in frameworks like React.Js. In conclusion, embracing these modern features brings not only clarity to your code, but also reflects the evolution of JavaScript itself. As web applications grow more complex, having these tools at your disposal will allow you to create scalable, maintainable, and efficient applications. Thanks for joining me on this journey through modern JavaScript. Keep practicing, and you'll soon find yourself mastering these concepts and applying them confidently in your own project. Building fast and scalable single-page applications using React.Js is not just about writing code, it's about understanding the architecture behind it. Today, we'll dive deeply into React.Js application architecture, exploring various components, state management, and the principles that help in creating efficient applications. So far, we learned about the significant evolution of JavaScript, focusing on ES6 features such as variable declarations with let and const, template literals for easy string interpolation, and arrow functions that simplify syntax and context management. We also explored destructuring for easier variable assignment from arrays and objects, the spread and rest operators for handling lists, and the introduction of classes for structured inheritance. Furthermore, we discussed modules for better code organization and promises with async await for efficient asynchronous handling. Together, these tools enhance coding practices and are essential for building scalable web applications. Now let's take a look at a basic functional component called greeting, which serves as a great introduction to React's component system. In this example, we define the greeting component as a simple JavaScript function that returns a JSX element, specifically an h1 tag displaying a welcoming message. This showcases how easily React allows us to create UI elements using a syntax that resembles HTML, thanks to JSX. Next, we will write a more dynamic version of this component, where we enhance its functionality by including props. We modify the greeting component to accept a prop called name, enabling the component to render a personalized greeting message. By using curly braces within the JSX, we can embed JavaScript expressions such as variables, allowing the component to dynamically display content based on the name prop passed to it. This illustrates not only the reusability of components in React, but also how they can be composed together to create more complex user interfaces by nesting components. Now let's implement a simple counter component using the useState hook. In this component, we start by importing React and the useState hook from the React library. The counter function is defined as a functional component. Inside this component, we use the useState hook to create a state variable called count, which is initialized to 0. This variable will hold the current count value, while setCount is the function we will use to update this count. In the return statement, we include a div element that contains an h1, displaying the number of times the button has been clicked, which is represented by count. Importantly, we also add a button that, when clicked, triggers the setCount function to increment the count by 1. This mechanism leverages React's state management, ensuring that whenever the button is clicked, the component re-renders, displaying the updated count seamlessly. This illustrates the dynamic data handling in functional components, showcasing how the user interface stays in sync with the underlying state. Now let's take a closer look at how to implement actions and reduces in Redux. First, we define an action type called increment, which serves as a constant to identify the action clearly. The increment function, when called, returns an action object with a type property set to increment. This indicates that an increment operation has been triggered. Next, we move to the reducer, which will manage the state of our counter. We initialize the state with an object containing a count property set to 0. The countReducer function takes the current state and an action as arguments. Using a switch statement, it checks what action occurred. If the action's type is increment, a new state object is returned, copying the existing state and updating the count by incrementing it by 1. If it encounters any other action type, it simply returns the current state, ensuring that unrecognized actions won't alter the state. Now let's see how we can set up the Redux store using the createStore method, which allows our application to manage and access state globally. We wrap our main app component with a provider, which supplies the Redux store to all connected components. This way, we ensure a consistent state is maintained throughout our application, enabling seamless interactions with the counter component. Next, we will implement routing in our React application using React Router, a library that provides essential tools for navigation in single-page applications. First, we install the library using npm, which allows us to include it in our project. Once it's installed, we'll set up our application structure by importing necessary components, namely browser router, root, and switch from React Router DOM. Now let's create the main app component where we'll define the routes. The browser router component wraps the entire application, facilitating the routing functionality. Inside it, we utilize switch to encapsulate our routes, ensuring that only the first matching route is rendered. We define multiple route components for different paths, the home path / that displays the home component and an about path that shows the about component. Finally, we also include a fallback route that directs to a not found component, which ensures that users receive feedback when navigating to undefined routes. This comprehensive setup allows for a seamless user experience and enhances navigation without full page reloads, embodying the single-page application ethos effectively. Now let's see how we can implement styled components to style our React components. First, we need to install the styled components library, which allows us to write CSS within our JavaScript files. This approach eliminates the need for separate CSS files and keeps our styles closely tied to the components they affect, enhancing maintainability and readability. Next, we define a styled button using the styled components API. We create a new component, styled button, which is a styled version of the standard button element. Inside the template literal, we specify the CSS rules. The button has a blue background, white text, padding, no border, and rounded corners to give it a smooth appearance. Moreover, we've added a hover effect that changes the button's background color to dark blue when the user hovers over it, which enhances user interactivity. Finally, we render the styled button in the app component, encapsulating its appearance and behavior. This straightforward yet powerful syntax allows for a more modular approach to styling in React, helping to keep our UI consistent and visually appealing throughout the application. Next, we will implement a component that demonstrates how to efficiently handle expensive computations in React using the useMemo hook. In our expensive component, we define a function called computeExpensiveValue that simulates a time-consuming calculation involving the parameters r and b. This function iterates 1 billion times, adding r and b to a result variable, mimicking a resource-intensive operation. To optimize performance, we use the useMemo hook, which memos the computed result of computeExpensiveValue based on the values of r and b. This means that if either of these inputs does not change between renders, React will skip recomputing the value, effectively reducing unnecessary processing time and enhancing overall application performance. The memoized value is then rendered in an h1 element, displaying the computed result to the user. By employing useMemo, we're ensuring that our component remains responsive and efficient, even when handling costly computations. This practice is essential for building scalable React applications, particularly as they grow in complexity and size. So we have traversed through the essential elements of React.Js application architecture, starting from components and state management to routing and styling, all while keeping performance in mind. Understanding these foundational aspects is critical for building efficient, scalable, and maintainable single-page applications with React.Js. With all these tools and knowledge at your disposal, you can create powerful applications that provide hassle-free user experiences. I hope this journey through React was engaging and enlightening. As you continue to build your own applications, keep practicing these concepts and don't hesitate to experiment. Happy Web development is exciting, ever-evolving, and at its core, powered by 3 essential technologies: HTML, CSS, and JavaScript. By mastering these 3 building blocks, you can create any front-end application and bring your ideas to life on the web. So far, we have learned about the essentials of building scalable single-page applications using React.Js. We focused on components, state management with hooks, and the use of libraries like Redux for global state management. We discussed the importance of routing with React Router for seamless navigation and explored styling options using styled components. Performance optimizations, including memoization with useMemo and useCallback, are crucial for enhancing application efficiency. This foundational knowledge is key for creating maintainable and efficient React applications. Now, let's dive into the core technologies behind web development that power your applications. Now let's take a look at a basic HTML structure to understand how we can lay out the contents of a web page effectively. This example starts with a declaration of the document type, which tells the browser that we are using HTML5. The HTML tag contains the entire content of the page, and the lang attribute specifies the language for accessibility purposes. Next, inside the head section, we define the character set and viewport settings to ensure that our web page is responsive on various devices. The title tag is essential for setting the title of the web page, which appears in the browser tab. Moving to the body, we begin with a header section that contains a main heading, welcoming visitors to the web page. Below that, the main element houses the primary content, where we have a paragraph that describes the purpose of this simple HTML page, followed by a link that directs users to an external website. This demonstrates how we can create functional elements with HTML. Finally, the footer section provides a closing remark along with the copyright notice. This structured approach using semantic tags helps establish a clear hierarchy and improves accessibility, making it easier for both browsers and users to navigate the content. Now let's see how we can implement some basic styling using CSS. In our CSS code, we start by defining the overall appearance of the web page, beginning with the body selector. Here we set the font family to Arial, ensuring a clean and modern text presentation, and adjust the line height to enhance readability. We also remove any default margin and padding, giving us more control over how elements are spaced. Next, we style the header. It features a dark background color alongside white text, creating a strong contrast that draws attention to the title of the page. We apply padding to give the header some breathing room and center the text to create a balanced look. For the main content area, we introduce padding to separate the content from the edges, thereby improving its visual appeal. We also style elements to provide a specific color for links using a vibrant blue and eliminate the default underline, which allows us to create a more modern and sleek design. Finally, we conclude with the footer, mirroring the header's styling to maintain a consistent theme. This approach not only enhances the overall aesthetics of our web page, but also ensures that the content is easier to read and navigate. Now let's see how we can implement a simple interactive feature using JavaScript. The code begins with a button element that has an ID of alert button. This button serves as the trigger for our interactive functionality. The next part of the code utilizes JavaScript to set an event listener on this button. When the button is clicked, the defined function will execute, which triggers an alert message saying, "Hello, you clicked the button." This showcases how JavaScript can dynamically interact with HTML elements, enabling user engagement right on the web page. By manipulating the document object model DOM with the document_getElementById method, we can easily access the button and attach functionality to it. This example illustrates the fundamental concept of event handling in JavaScript, where we can respond to user actions, enhancing the interactivity of our web applications. As you grow more comfortable with JavaScript, you'll be able to implement more complex functionalities such as form validations and dynamic content updates, building a richer user experience on your web pages. Now let's see how we can implement a reusable button component in React. The code begins by importing the React library, which is essential for building components. We define a functional component named alertButton. Inside this component, we create a function called handleClick. This function will be executed when the button is clicked, triggering an alert that displays a friendly message to the user. Next, we return the JSX that represents the button itself. Here, the button element is defined with an onClick event listener attached, which links it to the handleClick function. This means that whenever a user clicks the button, the alert will pop up, demonstrating the interactive capabilities of React components. Finally, we export the alert button component so that it can be imported and used in other parts of our application. This approach encapsulates the button's functionality and appearance, making it easy to reuse throughout our app while adhering to React's component-based architecture, ultimately promoting cleaner and more maintainable code. Now let's implement the following code to create a dynamic greeting message using template literals, a modern JavaScript feature. In this snippet, we first declare a constant variable named username and assign it the string value John. Template literals enclosed by backticks allow us to easily embed expressions within strings. Here, we create another constant called greeting that utilizes this feature. By embedding the username variable inside the backticks and denoting it with, we can dynamically create a personalized greeting. When we run the code, the greeting variable constructs a complete string. "Hello, John, welcome to our website." This approach simplifies string manipulation compared to traditional concatenation methods, making the code more readable and concise. Finally, we log the greeting to the console using console.log, which outputs the message. This functionality illustrates how template literals not only enhance clarity, but also make it easier to work with dynamic data in our applications. Now let's see how we can fetch data from an API using JavaScript's Fetch API. The code begins with the fetch function, which initiates a network request to the provided URL. This function returns a promise, meaning that it operates asynchronously, allowing other tasks to run in the meantime. Once the request is made, we use the then method to handle the response. In the first then, we convert the response to JSON format using response. JSON, also a promise that resolves with the data returned from the API. The next then method takes this data and logs it to the console, allowing us to see the fetched posts. In case of any errors during the fetch operation, we use catch to catch and log the error message, providing a clear way to manage any issues that arise during the data retrieval process. Next, we will write a more refined version of this code using async await syntax. Here we declare an asynchronous function, fetch posts, that allows us to await the completion of the fetch request. With try catch, we create a cleaner structure for handling errors, while beneath it, const response equals await fetch pauses execution until the data is fetched, making the code easier to read and maintain. Finally, we invoke this function to initiate the data fetching process and log the results, showcasing the smoother handling of asynchronous operations that async await provides. So to sum up, web development revolves around mastering HTML, CSS, and JavaScript. These technologies work seamlessly together to create dynamic, visually appealing web applications. From simple one-page sites to complex single-page applications built with libraries like React.Js, understanding these core technologies is fundamental to your success as a web developer. As you advance, you'll find that frameworks and modern JavaScript features will not only add depth to your applications, but also enhance your coding efficiency. This understanding sets the stage for building robust and effective web solutions. We're just getting started, so stay tuned as we explore how to leverage these technologies to create beautiful and scalable applications. JavaScript has had many versions over the years, and ES6 is one of the standout releases that transformed the way we write code, especially when it comes to frameworks like React.Js. Today, we'll explore modern JavaScript features that enhance our React applications, pushing our development skills to the next level. So far, we've learned about the fundamental technologies of web development, HTML, CSS, and JavaScript. We discussed how HTML provides structure, CSS adds style, and JavaScript enables interactivity to create dynamic web applications. The importance of frameworks and libraries like React.Js has been highlighted for building maintainable and scalable applications. Lastly, modern JavaScript features enhance code readability and functionality, setting the stage for more robust web solutions. Now we will talk about the exciting features introduced in ES6 and beyond that make React.Js development more effective. Now let's see how we can implement arrow functions in a React component. In the example, we create a class component called myComponent that extends React component. Within this class, we define a method handleClick using an arrow function syntax. This is significant because arrow functions automatically bind the this value to the component instance, eliminating the need for manual binding in the constructor. This feature simplifies our code, especially in larger components where managing the context of this can become cumbersome. In the render method, we return a button element that when clicked triggers the handleClick function. The console will log a message indicating that the button was clicked, along with confirming the correct context of this. This approach allows us to focus more on the functionality of the component rather than dealing with this context issues, thereby enhancing our development experience and making our code cleaner and more maintainable. Next, we will implement template literals, a feature that revolutionizes string management in JavaScript. This allows us to create multi-line strings and embed expressions directly, making our code much cleaner and enhancing readability, especially in React components. Now let's take a look at how we can utilize template literals to craft personalized messages. For instance, we define a variable named username to hold the value Alice. With template literals, we can seamlessly include this variable within our greeting string, creating a friendly welcome message while eliminating the fuss of traditional string concatenation. Additionally, we structure our user message using multi-line capabilities, making it easy to display updates in an organized manner. In the welcome message function, we return a JSX element that incorporates both the greeting and the user message within a div. This enhances our component's render output, allowing for dynamic and readable strings to be presented without messy syntax. By using template literals, our code reflects a clearer intent and is more maintainable, particularly beneficial when working with complex or longer strings in React development. Next, we will write a functional component called userProfile, showcasing how to effectively utilize destructuring and default parameters. In this component, we directly destructure the name and age properties from the props object. This approach not only simplifies how we access these values, but also enhances the clarity of our code. By setting a default value for age as unknown, we ensure that the component remains functional and predictable, even if the age property isn't provided when the component is used. Now let's take a closer look at the structure of our component. Inside the return statement, we are rendering a simple JSX layout that displays the user's name prominently in an H1 tag and their age in a P tag. This straightforward presentation of information places emphasis on readability and ease of understanding. Using default parameters coupled with destructuring allows us to write cleaner code and better express our component's intent, making it more approachable for other developers who may work with our code in the future. This practice is particularly beneficial in the context of React, facilitating a more efficient way to manage props and promoting best practices in component design. Now let's see how we can implement a simple shopping list component that demonstrates the use of the spread operator in state management. Here, we define a shopping list class that extends React component. It maintains a state that holds an array of items, starting with apples and bananas. Next, we create a method called addItem, which is responsible for adding a new item to our shopping list. We use the setState function with a callback that receives the previous state. Inside this callback, we employ the spread operator to create a new array containing all the previous items plus the new item. This approach is crucial because it preserves immutability by preventing direct mutation of the state, allowing React to correctly detect changes and efficiently trigger re-renders. In the render method, we display the list of items in an unordered list and provide a button that, when clicked, calls the addItem method to add oranges. This example not only highlights clean syntax, but also emphasizes the importance of immutability in React state management, ensuring our components respond optimally to updates. Now let's take a look at object shorthand syntax in action. This feature allows us to define object properties more succinctly when the property names match the variable names. In our example, we start by declaring two variables, age and name. Instead of explicitly stating these variables as object properties by writing name and age, we can simply include the variable names within the object literal. This makes our code cleaner and minimizes repetition, as JavaScript automatically understands that the property names correspond to the variable names. Next, we create a userCard functional component. Within this component, we access the user object's properties, username and useAge, directly in our JSX. This usage demonstrates how object shorthand syntax enhances readability, allowing us to focus on functionality without unnecessary clutter. By embracing this feature, we streamline our code and leverage JavaScript's capabilities more efficiently, which is particularly beneficial in a React context where maintaining clean and understandable code is vital for collaboration and future development. Now let's implement a data fetching mechanism using the async await syntax within a React component. In this example, we create a data fetcher class that extends React component. We start by initializing the state with data set to null, which will hold our fetched information once the API call is successful. Next, we utilize the component didMount lifecycle method, where the magic happens. This method is perfect for executing code after the component mounts, and here we'll fetch data from an external API. By declaring the method as async, we enable the use of await for handling promises seamlessly. Inside a try block, we perform a fetch operation to retrieve posts from a placeholder API. Upon receiving the response, we convert it to JSON format, and once this is successful, we update the state with the fetched data. Should any errors occur during this process, the catch block will catch them gracefully, logging the error to the console without disrupting the user experience. In the render method, we check if data is available. If not, we display a loading message. When the data is ready, we map through the posts, rendering each title in a list format, making our interface dynamically populated with content fetched from the API. Now let's take a look at how we can organize our React components into separate files using modular imports and exports. In the user.js file, we define a functional component called user that receives a name property. The component returns an H1 element displaying the name passed to it. By using the export keyword, we make this component available for use in other files. Next, we move to app.js, where we import React in our user component. The import statement specifies the path to the user component, allowing us to incorporate it into our app. Inside the app component, we utilize the user component by rendering it within a div, passing a prop with the name Alice. This setup not only keeps our code organized, but also exemplifies the principle of separation of concerns. By having components divided into different files, each with its specific responsibility, we increase code reusability and maintainability, which is essential for larger React applications. This modular structure helps developers manage and scale their projects effectively, ensuring a smooth development experience. In conclusion, modern JavaScript features, particularly those introduced in ES6 and beyond, bring powerful tools to the table that greatly enhance our React development experience. These features improve our code quality, readability, and efficiency, ultimately allowing us to build more maintainable and scalable applications. As we continue on this journey, remember that mastering these modern JavaScript features is key to unlocking the true potential of React.Js. So go ahead, experiment with these features in your own projects and see the difference they make. With every line of code, you're getting closer to becoming a pro at web development. Let's keep building, keep coding, and keep learning together. Happy. Now let's see how we can implement a simple car class to encapsulate the properties and behavior associated with cars. In this code, we define a car class with a constructor that initializes three car properties: make, model, and year. These properties are essential to uniquely identify each car instance. Following the constructor, we create a method called displayInfo, which constructs and returns a formatted string containing the car's details, showcasing how the private data can be encapsulated. When we instantiate a new car object using the new keyword, we pass in specific values for make, model, and year. This demonstrates object instantiation in JavaScript, allowing us to create unique car objects. Finally, we call the displayInfo method on the newly created car instance to retrieve and log its information. This approach illustrates the power of classes in JavaScript, encapsulating both data and methods, thereby enabling better organization and reuse of code, especially as we scale up our applications. Now let's see how we can implement a subclass to demonstrate the concept of inheritance in JavaScript. We begin by creating the electric car class, which extends the existing car class. By using the extends keyword, our electric car class inherits all the properties and methods from the car class, allowing us to build upon the existing functionality. Inside the constructor of electric car, we call the parent class constructor using super, passing the required parameters inherited from the car class, and we also define a new property, battery capacity, which is specific to electric cars. Next, we override the displayInfo method to customize the output for our electric car instances. By using super displayInfo, we leverage the parent method to get the standard car information, and then we append additional details about the battery capacity. This combination of inheritance and method overriding not only allows us to reuse code from the car class, but also provides the flexibility to enhance it with more specific behaviors relevant to the electric car. Finally, we create an instance of electric car and display its information, illustrating how inheritance can lead to cleaner and more organized code. Now let's see how we can implement encapsulation using private fields in a class with our bank account example. In this code, we define a bank account class featuring a private property called balance that stores the account balance. By prefixing the property name with a hash, we ensure that it can only be accessed within the class itself, promoting data encapsulation. The constructor takes an account number parameter, initializing it while setting balance to 0. This design safeguards the balance from direct manipulation. To interact with this property, we provide two public methods, deposit and getBalance. The deposit method allows adding a specified amount to balance, enforcing a rule that only positive amounts can be deposited. This functionality demonstrates how we can control data access and maintain the integrity of the internal state. The getBalance method provides a way to retrieve the current balance without exposing direct access to modify it. This encapsulation promotes safety in our code, ensuring that account balances are managed through controlled interactions, thus protecting against potential errors or misuse. Now let's implement a utility class that showcases the use of static methods. In this example, we will create a class named mathUtils, which contains two static methods, add and subtract. These methods provide simple mathematical operations that do not require any instance-based data, allowing them to be called directly on the class itself without needing to create an object. This makes invoking these functions convenient and straightforward, which is especially beneficial for utility purposes. The add method takes two parameters, x and y, and returns their sum, while the subtract method returns the difference between the same two parameters. By defining these methods as static, we can maintain a clear and organized approach to utility functions within our code base. Next, we will demonstrate how to use these static methods by logging their results to the console, highlighting that calling mathutils, add 5, 10, will output 15, and mathutils, subtract 10, 5, will yield 5. This approach not only enhances code readability, but also reinforces the principle of keeping utility functions separated from class instances, emphasizing their role as standalone helpers. Now let's examine the concept of method chaining through the implementation of the builder class. This class is designed to facilitate the construction of a string by employing an elegant chaining technique. The constructor initializes an empty string property called result. As we move through the methods, the add method plays a crucial role. It takes a value as an argument, appends this value to the result, and importantly, returns the instance of the builder itself. This return statement is what allows us to chain multiple calls to add sequentially. Next, we can call the build method, which finalizes the string construction and returns the complete result. To see this in action, we instantiate the builder class and utilize method chaining to append hello and world together. Finally, we console log the output. This practice not only streamlines the coding process but also enhances readability and expressiveness, allowing for a more fluid programming style as we construct complex strings with minimal syntax. Now let's take a look at how we can utilize JavaScript's prototype-based inheritance to define methods for our classes efficiently. In this example, we begin by defining a dog class, where we set up a constructor that initializes the dog's name property. Instead of defining methods directly within the class, we extend the dog class's prototype to include a bark method. By doing this, we efficiently allow all instances of dog to share this method, which saves memory and promotes clean coding practices. In the bark method, we utilize a template string to output a message that includes the dog's name, showcasing how easy it is to integrate dynamic content. Following this, we create an instance of the dog class named myDog and assign it a name, Rex. When we call the bark method on this instance, it logs the message, Rex says woof, to the console. This approach illustrates how leveraging prototypes not only enhances memory efficiency, but also keeps our code organized and accessible across all instances of a class, a fundamental principle of object-oriented programming. Now let's take a look at the person class, which showcases how to encapsulate data using private fields in JavaScript. This class introduces a private property, age, designated by a hash symbol, ensuring that it cannot be accessed or modified directly from outside the class. This encapsulation principle is crucial in maintaining the integrity of an object state. Next, we define a constructor that initializes the name and the private age when a new instance of person is created. The real magic happens in the celebrate birthday method, where we increment the value of age by 1 each time the method is called. This method not only updates the age, but also provides a user-friendly message that celebrates the birthday, displaying the new age of the person. By using this approach, we control how the private age can be altered, promoting safe data management. The encapsulation of state through private fields is a powerful feature, enhancing the robustness of our code and ensuring that the internal properties remain unchanged from unintended access. To wrap things up, the advent of classes and methods in JavaScript has revolutionized how we approach coding. By leveraging the principles of object-oriented programming, we have better tools for structuring our applications, ensuring code reuse and maintainability. As we continue to explore advanced concepts of JavaScript, understanding these frameworks will profoundly benefit our coding practices, particularly in environments like React. Remember, with great power comes great responsibility. Embrace the structure that classes provide, and don't forget to keep your code clean, organized, and encapsulated. Happy coding, and see you in the next lesson where we'll continue to dive deeper into the wonderful world of Java. In this video, we're diving into the essential concepts of web development. As we embark on this journey, I'll guide you through the building blocks that make up the web, focusing on the front end, back end, and the technologies that connect them. By the end of this lesson, you'll have a solid understanding of the web development landscape. So far, we learned about advanced JavaScript concepts, particularly classes and methods, that enhance the organization and structure of code, especially in frameworks like React. We explored object-oriented programming principles, focusing on inheritance, encapsulation, and the use of private fields to improve data integrity. Additionally, we discussed static methods, method chaining, and prototype-based inheritance to promote code efficiency and readability. Ultimately, these modern JavaScript features provide developers with powerful tools for building scalable applications. Now, we will cover the fundamental web development concepts and how they play a crucial role in crafting functional and dynamic websites. Now let's take a look at a simple HTML document. This code begins with a declaration that specifies the document type, ensuring that the browser interprets it correctly as HTML5. Inside the HTML tag, we set the language attribute to English, which assists with SEO and accessibility. The head section includes essential metadata. The character set is set to UTF-8, which ensures proper rendering of characters, and we also define the viewport setting, allowing for responsive design on mobile devices. The title tag sets the title of the web page that appears in the browser tab. Moving into the body section, this is where we present content users can see and interact with. We start with an H1 tag that provides a main heading welcoming visitors to the page. Below that, there's a P tag that contains a paragraph of text providing essential information. Finally, we include an im tag to display an image, with a source attribute linking to the image file and an alt attribute that describes the image for accessibility purposes. This structure ensures a clear, well-organized presentation of information to users. Now let's implement some CSS to enhance the visual appeal of our HTML document. In this example, we start by selecting the body element to set its background color, making it a light gray for a clean look. We also define that the font family should be Arial, ensuring the text is modern and easily readable. To create some breathing space around the content, we add 20 pixels of padding. Next, we turn our attention to the heading level 1, H1. We've chosen a dark gray color to create a contrast with the background, making it stand out prominently on the page. This is essential, as the heading serves as the focal point of our content. Finally, we style the paragraph elements, P, by assigning them a lighter gray color for the text and setting the line height to 1.5. This adjustment not only improves readability, but also contributes to a more visually appealing layout by ensuring adequate spacing between lines. Overall, this CSS code helps to improve the presentation of the page, illustrating the separation of structure and style in web development. Now let's take a look at how we can introduce interactivity into our web pages using JavaScript. We start with a button element that users can click, which is defined by the button tag. The important part here is the onClick attribute, which tells the browser that when the button is clicked, it should execute the displayMessage function. Next, we define this function within a script tag. This function, displayMessage, contains a simple line of code that triggers an alert box with a message when called. This alert serves as a way to communicate with the user, confirming their action of clicking the button. It's a straightforward example of how JavaScript can enhance user engagement by responding seamlessly to user interactions. By incorporating this code, you are not only manipulating the web page, but also laying the groundwork for more complex interactions in future projects. Such techniques are fundamental in crafting dynamic, user-friendly websites, as they transform static elements into parts of an interactive experience, making the web more exciting and responsive for users. Now let's see how we can implement a simple server using Node.js. In this code, we begin by requiring the HTTP module, which provides utilities for creating HTTP servers. We then create a server instance using the HTTP createServer method, which takes a callback function that automatically receives two arguments, the request rec and the response res. Inside this callback, we set the HTTP response status code to 200, indicating that the request has succeeded. Next, we utilize the setHeader method to specify the content type of the response as plain text. As we move to the final stages of our request handling, we call the end method on the response object, sending back the message "Hello World" to the client and completing the response. To activate our server, we call serverListen and specify port 3000, ensuring that our server will listen for incoming requests on this port. Lastly, we include a callback function that logs a message to the console when the server is successfully running, allowing us to confirm that our backend is operational. This basic server setup is a crucial step in understanding how client-server communication works in web development. Now let's see how we can implement a simple interactive button in our React application. In this component, we start by importing React, which is essential to utilize its features for building user interfaces. We define a functional component named app, where we declare a function called handleClick. This function uses JavaScript's built-in alert method to display a message when the button is clicked. Next, we focus on the return statement of our app component, which describes what will be rendered on the web page. We wrap our content inside a div element to group it together. Inside this div, we include an h1 heading that greets users and a button element with an on-click event handler that triggers our handle-click function. This structure exemplifies React's component-based architecture, promoting reusability and separation of concerns. By encapsulating the button logic within this functional component, we make it easier to manage and modify. When users interact with the button, they receive immediate feedback through the alert, enhancing the overall user experience of our application. It's important to note that all this technology works together in what's often referred to as the three-tier architecture. This architecture comprises three layers: presentation, application, and database. The presentation layer is the front end where users interact. The application layer or backend processes requests and runs the business logic. Lastly, the database layer stores the data that power everything. As web developers, mastering how these layers interact is crucial. Whether you aim to create a beautiful front-end experience or build robust server-side applications, understanding the complete web development cycle is essential. To wrap things up, we've made our way through the foundational concepts of web development. We've discussed the front-end technologies of HTML, CSS, and JavaScript, as well as the back-end principles involving servers, databases, and frameworks. By grasping these foundational concepts, you are well on your way to becoming a competent web developer. In our next lesson, we will delve deeper into modern JavaScript, focusing on features introduced with ES6 and beyond. Understanding these concepts will prepare us as we dive into React and learn how to build dynamic web applications. So keep your coding fingers ready and your notepads handy, because the journey into the vast world of web development has just begun. See you next. Modern JavaScript has revolutionized the way we build applications, especially in the context of React. Today, I'll guide you through several key features introduced with ES6 and how these can be effectively used to enhance our React applications. We're going to explore how the new syntax and functionalities of modern JavaScript can make our code cleaner, more efficient, and easier to read. So far, we learned about the foundational concepts of web development, including front-end technologies like HTML, CSS, and JavaScript, as well as back-end principles involving servers and databases. We covered the importance of frameworks and libraries that streamline the development process by providing pre-built functionalities. Additionally, we discussed the three-tier architecture that encompasses presentation, application, and database layers. In our current lesson, we will delve into the modern JavaScript features introduced with ES6 and their application in React for building dynamic web applications. Now let's see how we can implement a simple counter component using React. In this example, we start by importing React and the useState hook, which enables us to manage state within our component. However, for this initial implementation, we will demonstrate a counter using a basic variable. Inside the counter component, we declare a variable named count and initialize it to 0. This variable keeps track of the number of times the button is clicked. We then define a function called handleClick that increments the count each time the button is pressed and displays the current count in an alert. Notice that this approach only shows the count value at that moment. It does not retain the count across re-renders, which is a limitation of using a simple variable instead of a state variable. Finally, we render a button that triggers the handleClick function when clicked. This straightforward example illustrates the use of variable scope with let, showcasing its block-scoped nature compared to var. As we progress, we will enhance this implementation using the useState hook to ensure the count persists across re-renders, enhancing the user experience. Now let's see how we can incorporate template literals in our React application. In the greeting component, we define a functional component that takes a single prop, name. Within the return statement, we use template literals to dynamically construct a greeting message, ensuring it reads seamlessly. This is done by enclosing our string in backticks and using the syntax to inject the name variable directly into the string. This approach not only enhances the clarity of the greeting message, but also eliminates the clutter often associated with traditional string concatenation methods. By leveraging template literals, we can write multi-line strings and interpolate variables easily, contributing to cleaner and more maintainable code. This is especially useful in React, where we often need to render dynamic content. The simplicity and readability of template literals make our components easier for others to understand, aligning perfectly with React's philosophy of building user interfaces that are straightforward and intuitive. Next, we will write a simple React component utilizing traditional and arrow function syntax to highlight the differences. In the first part, we define a class component named button with a method handleClick. However, using a traditional function for this method can lead to confusion regarding the value of this. When the button is clicked, this does not refer to the button component, resulting in unintended behavior in the console. To address this issue, we will implement a functional component called buttonArrow. In this version, we'll use an arrow function for the handleClick method. Arrow functions automatically bind the context of this to the enclosing scope, ensuring that when the button is clicked, this correctly refers to the buttonArrow component itself. This design leads to more predictable behavior when dealing with event handlers in React components, avoiding common pitfalls experienced by developers. Thus, by using arrow functions, we not only solve the context issue, but we also achieve clearer, more maintainable code. Now let's see how we can utilize destructuring in a React component to enhance our code's clarity and maintainability. In the example of the user profile component, we define a functional component that receives props for the user's name, age, and location. By destructuring these properties directly in the function parameter, we streamline the way we handle incoming data. This approach eliminates the need for repetitive code within the component body, allowing us to access name, age, and location variables directly. As we return JSX to render the user's information, we can easily place these destructured variables within the appropriate HTML elements. This not only makes the code cleaner, but also improves readability, as anyone reviewing the component can quickly assess what props are required without sifting through additional lines of code to extract them. Ultimately, using destructuring promotes better organization and efficiency in our React applications, encouraging best practices that make our components more maintainable and easier to understand. Now let's take a look at how we can leverage the spread operator in our React application. In this example, we start by creating a user object that holds some basic information, including the user's name, age, and location. This object serves as a source of props for our user profile component, which is designed to display this information. Next, we define the user profile functional component, which receives props and utilizes them to render the user's details within a structured layout, consisting of a heading and descriptive paragraphs. This approach allows for clear and organized presentation of the user information. Now let's implement the app component, where we'll incorporate the user profile. By using the spread operator, specifically user, we efficiently pass all properties of the user object as props to the user profile component in a single, concise line. This not only simplifies our code, but also enhances its readability and maintainability, making it easier to manage dynamic data. Overall, this implementation demonstrates how the spread operator can streamline prop management in React, which is especially useful for components expecting multiple properties. Now let's see how we can implement asynchronous data fetching in our React application using promises and async await. In this example, we create a functional component called userData, which utilizes the useState and useEffect hooks to manage the component's state and perform side effects. Inside the userData component, we declare a state variable, data, initialized to null, which will hold the user information we fetch from the API. We then define an asynchronous function called fetchData that handles the API call. Using the await keyword allows us to pause execution until the fetch promise resolves, making our code flow more intuitive. If the fetch operation is successful, we convert the response into JSON format and update the data state with the result. To trigger the fetchData function, we use the useEffect hook with an empty dependency array, ensuring it runs only once when the component mounts. The component then conditionally renders either the user's name, once the data is available, or a loading message while waiting for the response. This structured approach not only enhances readability, but also effectively manages asynchronous operations within our application. Next, we will implement a simple calculator using utility functions to demonstrate how we can utilize modules effectively in our React application. To begin, we create a separate file called utilities.js where we define two functions, add and subtract. These arrow functions accept two arguments and return their sum and difference, respectively. By using the export keyword, we make these functions available for import in other files. In our main application file, app.js, we import React and the previously defined utility functions. This highlights the modular organization of our code, allowing us to keep our utility functions separate from the main application logic. Within the calculator component, we utilize the imported functions to perform arithmetic operations. Specifically, we display the results of adding and subtracting two numbers, 5 and 3, directly within JSX. This approach not only promotes cleaner code and separation of concerns, but also enhances maintainability, making it easier to test and reuse these utility functions across different parts of the application. By organizing code in this manner, we can effectively manage dependencies and reduce complexity in larger applications. As we move forward, it's imperative to understand how these modern JavaScript features influence React's core principles, making it easier to handle state, props, and lifecycle methods. They not only enhance the readability of our code, but also promote best practices in writing React applications. So we've explored a range of modern JavaScript features, from let and const through to modules. These tools can dramatically improve your development experience and allow you to write cleaner, more efficient code. The take-home message today is to embrace these ES6 features, as they can enhance both your React applications and your overall JavaScript coding practices. Keep practicing, explore how these features can solve common problems in your code, and tune in for our next lesson, where we'll dive deep into using hooks in React to manage local component state and side effects. A fantastic world of possibilities awaits you as you enhance your development skills with these modern tools. Now let's take a look at the syntax of the map function and understand how it operates. In the first piece of code, we declare a new array called newArray, which is generated by calling the map method on an original array. This method takes a callback function as its argument, which will execute for each element of original array. The callback function receives the current element and its index as parameters, allowing you to define transformation logic specific to each element. This approach makes it easier to create a new array derived from the original while maintaining immutability. Next, we will implement a more concrete example of using map. Here, we have an array of numbers defined as numbers. By using map, we can succinctly define a function that doubles each number in the array. The result is stored in doubled numbers, which is a new array containing all the doubled values. Notably, this operation does not alter the original numbers array, illustrating the immutability principle that makes map a powerful tool in functional programming and React applications. Now let's see how we can implement a practical example of the map function with an array of user objects. Here, we define a constant variable users, which is an array of objects. Each object contains an ID, name, and age properties representing individual users. This structure allows us to work with complex data easily. Next, we use the map function on the users array to extract just the names of the users. By passing a callback function to map, we specify that for each user object, it should return the value of the name property. This concise operation transforms the original array of user objects into a new array called usernames, which solely contains the names of the users. Finally, we log this new array to the console, which will display an output of the user names together in a single array. This demonstrates how map facilitates the extraction of specific data from an array, promoting cleaner and more efficient code while preserving the original structure of the data. Now let's see how we can implement a userList component that utilizes the map function to display usernames from an array of user objects. This component receives a prop called users, which is expected to be an array of user objects, each containing at least an id and a name. In the return statement of the component, we start by creating an unordered list all. Inside this list, we invoke the map function on the users array. The map function iterates over each user object, allowing us to access properties such as userid and username. For each user, we create a list item li that displays the user's name. It's essential to include a key prop for each list item, which we set to user ID. This is a best practice in React, as it helps the framework efficiently identify and manage each item in the list, especially as the list changes over time. By using map in this way, we not only ensure that our component is maintainable and efficient, but also demonstrate how seamlessly it integrates with React's rendering logic. Now let's take a look at how we can handle cases where our data might not be an array before using the map function. In the example, we first declare a variable called maybeArray and set it to null. This simulates a scenario where we might be uncertain if the variable we're dealing with is indeed an array. To safely apply the map function, we use arrayIsArray to check whether maybeArray is an actual array. If the condition evaluates to true, we can confidently call map on maybeArray, applying the transformation function to double each item. However, if maybeArray is not an array, we return an empty array instead. This practice of validating our data type before applying array methods is crucial in preventing runtime errors and unexpected behavior in our applications. By logging the result, we can see that when maybeArray is null, our code gracefully returns an empty array, demonstrating the importance of error handling when working with array functions. This approach not only improves code stability, but also enhances the user experience by avoiding crashes. Now let's see how we can implement a scenario using filter and map to extract specific data from our array of user objects. In the following code, we start by filtering the user's array to create a new array that only includes users over the age of 30. This is accomplished by passing a callback function to the filter method that checks each user's age. Once we have this filtered array, we then chain the map method to transform this data further. Specifically, we want to create a new array that contains only the ages of these filtered users. As a result, the map method iterates over the filtered array and extracts the age of each user, creating a new array called authentication. Finally, we log this new array to the console, which will output the ages of users that meet our criteria. This method exemplifies how, by combining array methods, we can efficiently process and glean the necessary information from our data set in a readable and concise manner. Now let's see how we can implement an asynchronous data fetching example using the map function within a React component. In this code, we set up a functional component called userListWithFetch that utilizes React's useEffect and useState hooks to manage state and side effects. Initially, we declare two pieces of state, one for storing user data and another for tracking the loading status. When the component mounts, we use the useEffect hook to initiate an API call, which fetches user data from a mock URL. The fetching process is asynchronous, allowing us to handle data retrieval without blocking the UI. While the data is being loaded, a loading message is displayed to the user. Once the data is successfully retrieved, we update our state with the user data and set the loading status to false. This is where the power of map comes into play. As soon as the data is ready, we iterate over the user's array, transforming each user object into a list item that displays the user's name. This approach not only efficiently renders our data, but also demonstrates how map can seamlessly integrate into the data fetching process to bridge the gap between API responses and UI rendering. Now let's take a look at how we can format user names alongside their ages using the map function. In this example, we start with an array called users, which consists of user objects containing their names and ages. By employing map, we create a new array called formatted names that transforms each user object into a string that includes both the user's name and age in a more visually appealing format. The transformation function within map uses a template literal to structure the output string, ensuring that each name is displayed followed by their age, formatted as name age value. This method not only streamlines the process of data transformation, but also reinforces the principle of immutability, as we are not altering the original array of user objects. Instead, we generate a brand new array that can be used for display or further processing. Finally, we can log this formatted array to the console, allowing us to easily verify our transformations and see the resulting output, which is a concise representation of each user's name and age in a single formatted string. As we conclude our deep dive into the map function, it's clear that this array method is an essential tool for JavaScript developers, especially when working with frameworks like React. Its ability to create new arrays based on transformations not only promotes immutability, a crucial principle in React, but also fosters clean, readable, and efficient code. By embracing the map function, you've equipped yourself with a powerful means of processing data that can dramatically enhance your development workflows and overall application performance. As you continue to explore JavaScript and React, remember to take full advantage of map and its synergy with other array methods to craft elegant solutions to your programming challenges. So there you have it, a comprehensive overview of the map function, its usage, and how it integrates with React to help you build efficient applications. Keep practicing and experimenting with these techniques. Happy Web development is an expansive field, but at the core, we have three essential technologies that you must understand: HTML, CSS, and JavaScript. Mastering these three languages will empower you to build any front-end application. In this session, we'll dive deep into each of these technologies, covering their roles, interconnections, and providing practical code examples, particularly in the context of React.Js. So far, we've learned about the map function in JavaScript, which is invaluable for transforming arrays, and today we'll start with the foundation, the trio of HTML, CSS, and JavaScript. Now let's explore how to create a basic web page using HTML, which serves as the foundation of web content. The doctyp HTML declaration at the beginning specifies that this document is an HTML5 document. Within the HTML tags, we define the structure of our web page. The head section contains metadata, including the charset and viewport settings, along with a title that appears in the browser tab. Next, we move to the body section, where the visible content resides. Here, we incorporate a header element that greets visitors with a welcoming message using an H1 heading. This establishes the primary title of our page. Following that, the main element includes a descriptive paragraph that outlines the purpose of the web page, while also presenting a button. This button is particularly interactive, as it has an onClick attribute that triggers a JavaScript alert with a friendly greeting when clicked. Finally, the page concludes with a footer element, displaying a copyright notice to inform users of the website's ownership. This simple structure effectively demonstrates the role of HTML in organizing content and creating an engaging user experience. Now let's take a look at how we can enhance our HTML structure with CSS for better presentation. In the provided CSS code, we begin by setting a global font for the entire page using Arial, which is a sans serif font that creates a clean and modern look. We eliminate default margins and padding from the body and set a light gray background color, offering a subtle contrast to the content. Next, we style the header, giving it a dark background color and white text to ensure it stands out, coupled with appropriate padding for adequate spacing. The main content area is then defined with its own margin and padding, along with a white background and rounded corners to create a card-like effect that adds depth to the design. Lastly, we turn our attention to button styling, ensuring it has a vibrant background color that contrasts with the header and remains visually appealing. The button is equipped with a cursor change for interactivity and rounded corners to match the modern aesthetic of the web application. This implementation of CSS not only enhances the visual hierarchy, but also improves the overall user experience by making our web application more engaging and attractive. Now let's implement an interactive feature using JavaScript to enhance our web page's functionality. In this example, we use the document query selector method to target the button element we've defined in our HTML. This allows us to manipulate it directly through JavaScript. Next, we add an event listener to the button, specifically listening for a click event. This means that every time a user clicks the button, the function we define within the listener will execute. Inside this function, we call the alert function, which displays a pop-up message saying, "Hello, world." This simple interaction demonstrates how JavaScript brings dynamism to static content served by HTML. By enabling real-time responses to user actions like button clicks, we enhance user experience and engagement. This code snippet is an excellent starting point for understanding how JavaScript operates in the browser, bridging the gap between static content and interactive interfaces. As we continue to build more complex functionalities, understanding these fundamentals will be crucial for creating seamless web applications. Now let's take a look at how we can define a simple React component that will display a welcome message. Here, we start by importing React from the React library, which is essential for working with these components. The function welcome component is a functional component that returns a JSX structure, which resembles HTML but is more powerful. Inside this component, we have a div container holding an H1 element and a button. The header displays the message, "Welcome to React," which serves to introduce the application's purpose. The button has an onClick event handler that triggers an alert with the message "Hello from React" when clicked. This illustrates how we can create interactive elements within our components, making them respond to user actions. Finally, the component is exported as the default export, allowing it to be imported and utilized in other parts of the application. This modular approach highlights one of React's core principles, building reusable and self-contained components that enhance the structure and maintainability of our code, especially in larger applications. So far, we covered the essential building blocks of web development: HTML for structure, CSS for style, and JavaScript for functionality. We examined how these technologies work together to create a seamless user experience while touching on the advantages of using a library like React.Js. Now, we will talk more about how to style React components using CSS and how to manage state within those components. Now let's see how we can implement scoped styles in our React application using CSS modules. In this example, we begin by importing the necessary modules, React and our CSS styler sheet, which is named app module CSS. This CSS module allows us to define styles that are locally scoped to this component, reducing the chances of class name conflicts that can occur in larger applications. Within the app function component, we structure our component's return statement to render a div that uses a class name derived from our imported styles. The styles container provides specific styling for the outer container, ensuring that it adapts only to this component. Similarly, we utilize styles title for the h1 element, giving it a unique appearance within the context of this component without affecting other elements in the application. We also assign a class from our CSS module to the button using styles button, which enhances its design and functionality. The button additionally has an on-click event that triggers an alert when clicked, illustrating not only styling but also interactivity in a single component. This demonstrates an efficient way to manage styles in a React application while keeping the code organized and maintainable. Now let's see how we can implement state management in a React component. In this example, we create a simple counter component that tracks a count value using the useState hook. This hook is a built-in React function that allows us to add state to our functional components. We initialize the count with a value of 0. As the component renders, we display the current count in an h1 tag. The true interactivity comes from the buttons we create, one to increase the count and another to decrease it. Each button has an on-click event handler that directly updates the count state by calling the setCount function provided by the useState hook. This is crucial because whenever the state is updated, React re-renders the component, showcasing the updated count in the UI. This approach demonstrates how state management allows us to create dynamic and responsive user interfaces in React. By leveraging hooks like useState, we can build components that not only display information, but also engage users by responding to their interactions seamlessly. As we wrap up our discussion, we can easily see how HTML, CSS, and JavaScript are the fundamental technologies for front-end web development. They serve as the foundation upon which powerful frameworks and libraries like React.Js can be built. By mastering these core technologies, you will be well equipped to tackle web development challenges and create stunning, dynamic web applications. Keep exploring, keep coding, and embrace the joys and challenges of web development. JavaScript has had many versions over the years, and ES6 is one of the JavaScript versions that introduced a wide array of modern features to the language. In today's lesson, we will dive deep into the modern features of JavaScript, particularly focusing on those introduced in ES6 and beyond. So far, we learned about the essential technologies in web development. HTML provides structure, CSS handles presentation, and JavaScript adds functionality. We explored how these technologies work together to create interactive web applications, particularly through the use of React.Js. Additionally, we discussed CSS modules for styling React components and the importance of state management using hooks. By mastering these core elements, you are well prepared to build dynamic and engaging web applications. Now, we will cover the modern features in JavaScript that make coding more efficient and expressive. Now let's take a look at how we can implement traditional functions alongside their arrow function counterparts. In our first example, we declare a traditional function called add that takes two parameters, a and b, and returns their sum. This syntax, while effective, tends to be more verbose. To showcase the benefits of the arrow function syntax, we define add_arrow, which achieves the same task using a much more concise format. With the arrow function, we eliminate the need for the function keyword and the curly braces when the function consists of a single expression. This not only shortens our code, but also enhances readability. Furthermore, one of the key advantages of arrow functions is that they do not bind their own this context. This feature is particularly beneficial when functions are used as callbacks, as it maintains the expected context without requiring additional work. By invoking both add and add_arrow, we can see that they produce the same output, demonstrating how arrow functions offer a streamlined approach to writing concise and context-aware code. Next, we will write an example using template literals, which provide a more convenient way to work with strings. In this code, we first declare two variables, name, which holds the string Alice, and age, which is set to 25. This sets the stage for creating a dynamic message. Now, let's see how we can implement this by using a template literal to craft our introduction string. We enclose the entire string within backticks, allowing us to seamlessly embed the variables name and age directly within the string using the syntax. This approach not only makes reading and writing the string easier, but also enhances clarity, as we don't need to deal with the cumbersome plus operator for concatenation. Finally, we use console.log to print this composed string to the console, which outputs a message stating the name and age dynamically. By using template literals, we improve the readability and maintainability of our code, particularly when working with dynamic values in applications like React, where JSX can be structured more naturally this way. Now let's take a look at destructuring, a useful feature in JavaScript that allows for more efficient extraction of values from objects. In our example, we define a user object containing 3 properties: name, age, and location. Instead of accessing these properties through the full object reference like username and useAge, we can streamline our code using destructuring. By creating a variable declaration with curly braces, we can extract name and age directly from the user object. This simplifies our code and enhances readability by making it clear which properties are being utilized. Next, we log the extracted values to the console, which outputs the name Bob and the age 30. By using destructuring, we not only reduce the verbosity of our code, but also clarify its intent, making it easier for others to understand. This approach is especially beneficial in React functional components, where parsing props can be tedious. Destructuring allows us to handle props more cleanly and efficiently directly in the parameter list. Now let's take a look at how we can efficiently combine arrays using the spread operator. In our example, we start with 2 arrays, one containing fruits called fruits, which includes apple and banana, and another array named more fruits that contains orange and kiwi. The beauty of the spread operator, represented by 3 dots, comes into play as we merge these 2 arrays into a single array called all fruits. By using the spread operator, we seamlessly insert the elements of both arrays into all fruits without modifying the original arrays. This results in a new array that neatly encompasses all the fruits, specifically displaying apple, banana, orange, and kiwi. This technique is particularly useful in React, where you might need to merge arrays or objects when updating state. You can spread an array of components directly into your JSX, enhancing readability and making your code cleaner. Thus, mastering the spread operator not only streamlines your coding process, but also empowers you to handle data structures more effectively in your applications. Now let's take a look at promises, a powerful feature for managing asynchronous operations in JavaScript. In the code, we define a new promise called fetchData. This promise uses a constructor function that takes 2 parameters, resolve and reject, which are functions to handle the completion of the promise. Inside the promise, we simulate an asynchronous operation using setTimeout, which waits for 2 seconds before executing the code within it. After that delay, we prepare the data to be returned, in this case, the string data received, and call resolve_data to indicate that the operation was successful and provide the result. Following the promise's definition, we utilize the then method to handle the successful outcome of the promise, logging the result to the console. This is where we can see the benefit of using promises, as it allows us to chain actions instead of nesting callbacks, thus avoiding callback hell. Moreover, the catch method can be employed to handle any errors that might arise during the asynchronous operation, ensuring our code is robust and can gracefully respond to potential issues. This structure provides a cleaner and more manageable way to deal with asynchronous tasks. Now let's see how we can implement asynchronous operations in JavaScript using promises and the async await syntax for better readability and flow. The code begins by defining a function called fetchData, which returns a promise. Inside this promise, a setTimeout simulates a delay before resolving the promise with a string data received after 2 seconds. This structure illustrates how promises allow us to manage asynchronous tasks more effectively compared to traditional callback methods. Next, we create an asynchronous function named handleData. Within this function, we use the await keyword to pause execution until the promise from fetchData resolves. This approach simplifies the process of handling asynchronous operations, as it allows the code to read linearly, similar to synchronous code. Finally, we invoke the handleData function, which will log data received to the console once the promise is fulfilled. This technique not only enhances code clarity, but also allows for more intuitive error handling using try-catch blocks, making our asynchronous JavaScript much more manageable. Now let's take a look at how to define and use classes in JavaScript, particularly focusing on inheritance and method overriding. In this example, we create an animal class that serves as a blueprint for all animals. The class has a constructor that accepts a name parameter, which gets assigned to the instance, allowing each animal to have its own unique name. The speak method is defined within the animal class, providing a generic implementation that outputs a message indicating the animal makes a noise. Next, we build on this base class by creating a dog class that extends animal, showcasing the power of inheritance. By using the extends keyword, the dog class inherits all properties and methods from animal. However, we override the speak method in dog to tailor its behavior specifically for dogs, ensuring it outputs a message that the dog barks. Finally, we instantiate a dog object named rex and call it speak method, confirming that our implementation correctly reflects the behaviors of these related classes in a clear and organized manner. This structure greatly enhances code readability and maintainability, essential for working on larger projects. Now let's take a look at how we can use modules to promote code reusability and organization in our JavaScript applications. In this example, we start with a separate file named Square.js where we define a function called square that takes a number, x, and returns its square by multiplying it by itself. By employing the export keyword, we make this function accessible to other files, allowing us to utilize it elsewhere in our project. Next, we move to our main file where we utilize the import statement to bring the square function from Square.js into our current context. This modular approach is beneficial as it helps maintain a clean code structure, especially in larger code bases, by keeping related functionalities separated. With the functionality imported, we then call the square function with the argument for and log the result to the console, which outputs 16. Overall, this demonstrates how the import and export syntax introduced in ES6 streamlines our development process and enhances maintainability by allowing us to compartmentalize our code into logical modules. As we conclude our exploration of modern JavaScript features, it's evident how these advancements enhance our coding experience with cleaner syntax, better organization, and improved efficiency for both beginners and seasoned developers. With arrow functions, template literals, destructuring, and promises, JavaScript has evolved significantly to meet the growing needs of developers. The inclusion of async await classes and modules further solidifies JavaScript's position as a powerful and versatile language in web development. Arming yourself with these modern JavaScript features will not only streamline your coding practices, but also set you on the path to writing more elegant, maintainable, and scalable applications. By incorporating these modern techniques, you're well equipped to delve into more complex scenarios, especially when developing applications with frameworks like React.Js. Remember, the goal is to continue practicing these concepts and apply them in real-world projects. Each feature complements the others, creating a more synchronized and effective development experience. So get coding and enjoy the exciting journey. Now let's dive into the fundamental concepts of web development, an essential foundation that every developer should grasp. Building on our journey so far, where we've explored the evolution of JavaScript, primarily focusing on modern features from ES6, let's now broaden our horizons. In this session, we'll unravel the core technologies at the heart of web development, essentially HTML, CSS, and JavaScript, and discuss how they shape our web applications, particularly in the context of React.Js. So far, we learned about the evolution of JavaScript, focusing on ES6 and its modern features that enhance coding efficiency and expressiveness. We covered essential web development technologies including HTML, CSS, and JavaScript and their synergy, especially within the React.Js ecosystem. We explored key concepts like arrow functions, template literals, destructuring, the spread operator, and the significance of asynchronous programming. Additionally, we discussed classes and modules that improve the organization of JavaScript applications. Now, we will talk about the very foundations of web development and how these three technologies work together to create dynamic and interactive web applications. Now let's take a look at a simple HTML structure that serves as the foundation for our web page. In this example, we begin with the declaration, doctyp HTML, to inform the browser that we are using HTML5. Following this, the HTML tag encapsulates everything within our document. Inside the head, we include essential meta tags. The character set declaration ensures that our text displays correctly, while the viewport meta tag makes our web page responsive on different devices. The title element defines what appears in the browser tab, giving users a clear context for our page. Next, we move into the body section where the visible content resides. The use of headings, such as H1, establishes a clear hierarchy, introducing the main topic of our page. Below it, a P tag contains our first paragraph, providing more detail and context to users. We also include a tag, creating a hyperlink that directs users to another website, thus enhancing navigation. This demonstrates how HTML effectively structures our content, setting the scene for further enhancements with CSS and JavaScript in upcoming sections. Now let's see how we can apply styles to our HTML document using CSS. The following code demonstrates how to enhance the visual appeal of our web page by defining specific styles for various elements. We begin by setting the background color of the entire web page to a light gray, creating a subtle yet attractive backdrop. Font family is defined as Arial, which ensures that the text is displayed in this clean and modern sans serif typeface, improving readability. For headings, we specify a color of dark gray, providing clear contrast against the light background, making them stand out. By applying a lighter shade of gray to the paragraph text, we ensure that it is legible while still being visually soothing. The line height property is utilized to increase the spacing between lines, enhancing readability further. Lastly, we style the anchor tags to be a vibrant blue with no underlines, providing a clear click target for users and encouraging interaction. This CSS implementation dynamically transforms our basic HTML structure into a polished, user-friendly design, showcasing the power and importance of CSS in web development. Now let's see how we can implement interactivity using JavaScript in our web application. In the example provided, we define a button with the ID myButton that when clicked triggers a function. This function accesses the paragraph element with the ID demo and updates its inner HTML content to say, "Hello, JavaScript." Notice how we use the document_getElementById method to reference these elements. This is a powerful feature of JavaScript, allowing us to interact with the document object model, DOM, dynamically. The onClick event handler is set up to respond to user interactions, illustrating how JavaScript enables responsive design. This simple yet effective interaction showcases the core principle of JavaScript in web development. It allows us to make static HTML elements come alive and respond to user actions. By utilizing JavaScript alongside HTML and CSS, we can create engaging web experiences that go beyond mere static content, bringing more value to our applications and enhancing user satisfaction. Now let's take a look at how we can create a simple React component. In this example, we define a component named welcome that accepts props as an argument. This allows the component to dynamically render content based on the properties passed to it. The main function returns a header element that displays a greeting, incorporating the props name value. To use this component, we can invoke it elsewhere in our application with a specific name, like React Developer. This demonstrates the core principle of components in React, encapsulation and reusability. Instead of repeating code for different greetings, we can simply pass different names as props. This approach not only streamlines the development process, but also promotes clean and maintainable code. Additionally, dealing with props in components fosters a more organized structure, making it easier to understand how data flows within the application. Overall, the design of React components empowers developers to build intricate user interfaces with elegance and efficiency. Now let's take a look at how we can effectively utilize destructuring in a React component. In this example, we define a user object that contains two properties, name and age. This encapsulates the information we want to display to the user. Next, we create a functional component called useInfo, which takes these properties directly from the user object using destructuring in its parameters. This approach enhances readability by allowing us to reference name and age directly within the component without needing to access them through the props object. The component returns a simple paragraph element that dynamically displays the user's name and age in a user-friendly format. Finally, we showcase how to use this component by spreading the properties of the user object into the useInfo component. This usage demonstrates how React enables clean data handling and concise implementation, ultimately reducing redundancy and improving the clarity of our code. By leveraging these ES6 features, we create a more elegant and maintainable code base that aligns perfectly with React's emphasis on simplicity and efficiency. Now let's implement a functional component in React that fetches and displays data from an API. In this example, we begin by importing the necessary hooks, useEffect and useState from React. These hooks allow us to manage our component's state and handle side effects, such as fetching data after the component has rendered. Inside the dataFetcher component, we initialize a state variable called data using useState, which starts as an empty array. This state will store the data we retrieve from the API. Next, we utilize the useEffect hook to execute a function when our component mounts. This function makes a call to the specified API endpoint, fetching data asynchronously. Once we receive the response, we convert it to JSON format and update our data state with the new information. Finally, in the return statement, we map over the data array to dynamically create an unordered list of items. Each item is rendered as a list element with a unique key, which is essential for helping React identify and manage list items efficiently. This exemplifies how powerful hooks can be in managing state and lifecycle events in functional components, particularly when dealing with data fetching in a React application. In conclusion, the combination of HTML, CSS, and JavaScript provides a robust framework for building web applications. Understanding the fundamentals of these technologies is crucial for any aspiring developer. With the advent of libraries like React.Js, we can create powerful, interactive applications that are both effective and pleasant to use. Just remember, the world of web development is vast, and mastering these fundamentals will serve as a stepping stone to more advanced topics down the line. Are you ready to embark on this journey of web development? That's what we'll explore in the following modules, where we will dive even deeper into React and discover its full potential. Keep coding, keep learning, and let the web development journey be exciting and fruitful. JavaScript has had many versions over the years, and ES6 is one of the JavaScript versions that introduced a plethora of modern features, enhancing the language's functionality and usability. In today's lesson, we will dive deep into the modern JavaScript features that are particularly relevant for React.Js development. So far, we learned about the foundational technologies of web development, specifically HTML, CSS, and JavaScript, and their integral roles in creating functional and interactive web applications. We explored how HTML structures web pages, CSS enhances their appearance, and JavaScript adds interactivity, exemplifying these concepts through coding snippets. Additionally, we delved into how React.Js utilizes these technologies to build single-page applications and manage components effectively, applying modern ES6 features for better code organization. As we continue, we'll further explore React and its capabilities in more depth. Now let's take a look at how we can implement an arrow function in JavaScript. The greetUser function is defined using the arrow function syntax, which allows us to create a function expression in a more concise manner. In this example, the function takes a single parameter, name, and returns a greeting message that incorporates the provided name using a template literal. This approach not only makes the code shorter and simpler, but also utilizes the backticks, which enhance readability by allowing us to embed the variable seamlessly within the string. Next, we execute the function by calling greetUser with the argument Alice, demonstrating how easy it is to generate a personalized greeting. The console log statement displays the returned result in the console, which in this case would read, "Hello, Alice." The use of arrow functions like this is particularly beneficial in React, where maintaining the correct context for this is crucial, especially in nested function calls or callbacks. This approach to function definition enhances both code clarity and efficiency, making it a popular choice for modern JavaScript development. Now let's take a look at how we can implement template literals for more dynamic string manipulation in our JavaScript code. In the code snippet provided, we start by declaring a constant variable, username, and assigning it the string value bob. This variable will hold the user's name that we want to incorporate into our greeting. Next, we utilize a template literal to create a more readable and expressive greeting message by surrounding the entire string with backticks instead of traditional quotes. Within the backticks, we can embed expressions, like our username variable, directly using the syntax. This allows us to create the greeting message, which dynamically incorporates the user's name, producing a personalized string, "Welcome back, Bob." Finally, we log this greeting to the console. Template literals not only enhance readability, but also support multi-line strings, making it easier to format our strings in complex scenarios, particularly when dealing with JSX in React. This feature greatly simplifies the code, promoting cleaner and more maintainable solutions for developers. Now let's see how we can implement destructuring assignment effectively. In the first code snippet, we have an object named user that contains two properties, name and age. Using destructuring, we can extract these values into distinct variables in a concise manner. By declaring const name age equals user, we are able to unpack the properties directly from the object, eliminating the need for repetitive referencing like username and useage. This not only makes the code cleaner, but it also enhances readability, allowing us to see at a glance what variables we are working with. Next, we will write a functional component called userProfile. Here, we utilize destructuring right in the function parameters, allowing us to neatly access name and age from the props being passed into the component. Inside the component, we return a simple JSX structure that displays these values in a user-friendly manner. This technique of destructuring props directly helps maintain clean and organized code, making the component easier to manage and understand, especially as it grows more complex. Through this approach, we see the power of modern JavaScript features in streamlining our React development process. Now let's implement the following code using the spread operator, a powerful ES6 feature. The first snippet defines two arrays, array1 and array2, each containing a set of numbers. By using the spread operator, we can create a new array called combined array that merges the elements of both arrays without altering the original arrays. This seamless combination ensures that we maintain immutability, which is particularly crucial in React for state management. In the next part, we demonstrate how to manage state effectively. Here, we start with an initial state array containing some numbers. By employing the spread operator again, we can create a new state array that adds an additional number, far, to the original state. This approach ensures we are not modifying the existing state directly, but rather creating a new one, which aligns perfectly with the principles of React state management. Embracing the spread operator in this way simplifies the way we handle updates, making our code cleaner and more maintainable. Now let's take a look at how we can implement classes in JavaScript, which provide a clear syntax for creating objects and managing related data and behavior. In the first example, we define a class called animal with a constructor that initializes the name property. This encapsulation is key as it allows us to create distinct instances of animal with their own unique names. The speak method within the class provides functionality, enabling each animal instance to produce a specific message based on its name, demonstrating how classes bundle data, properties, and methods, functions together. Next, we shift our focus to a practical application of classes in React by creating a greeting component that extends React component. This structure makes it easy to manage the component's lifecycle and state. Inside the render method, we return an h1 element that dynamically greets the user with the name passed through props. This example illustrates the power of classes in React, allowing us to build robust, reusable components that can inherit behaviors from other components, enhancing our React application's organization and scalability. Next, we will write the following code to illustrate how to utilize CSS Modules, an essential feature for organizing and sharing code efficiently in JavaScript applications. We start with a separate file named myModule.js, where we define a function called add that takes two parameters, a and b. This function uses an arrow function syntax, allowing us to write concise code that returns the sum of these two values. By using the export keyword, we make this function available for other modules to import and use, promoting code reuse and clarity. Now let's see how we can import the add function into another file. We use the import statement, specifying that we want to import add from our myModule file. With this action, we can easily call the add function anywhere in our current module. In our example, we call add53 and log the result to the console, which outputs the sum of these two numbers, 8. This use of modules allows for better management of dependencies and encourages a clean and maintainable code structure as our project scales. Now let's implement a simple example of using promises to handle asynchronous operations. In this code, we define a function called fetchData that returns a new promise. Promises are critical for managing tasks that take time to complete, such as API calls. Within the promise, we use setTimeout to simulate a delay, representing an asynchronous action, and then call the resolve function after 2 seconds to simulate successful data fetching. This setup allows us to retrieve a value once the operation is complete. We then invoke fetchData and chain the then method to handle the resolved value, which gets logged to the console. This demonstrates how promises allow for a more organized way to deal with asynchronous code, as you won't have to rely on complex nested callbacks. Next, we'll look at how to integrate promises with an even cleaner alternative using async-await syntax. Here, we define a function called fetchUser that fetches user data from an API. By using the await keyword, we pause execution until the fetch call returns a response, making the code easier to read and maintain. The response is then converted to JSON format, allowing us to directly return the user data. Finally, we call fetchUser and log the returned user to the console. This approach enhances our ability to write straightforward asynchronous code, improving our development workflow significantly. In summary, modern JavaScript features introduced in ES6 have fundamentally enhanced how we work with React.Js. Features like arrow functions, template literals, destructuring, the spread operator, classes, modules, and promises empower us to write cleaner, more maintainable, and efficient code. These advancements not only help improve developer experience, but also optimize the performance of our applications. As we continue our journey in the world of React, it's essential to understand and leverage these features to their fullest potential. Next, we will dive deeper into the intricacies of React itself, exploring components, state management, and what it truly means to build reactive user interfaces. Buckle up, it's going to be an exciting ride through the world of modern web development. Let's dive into the fundamental concepts of web development. This tutorial will guide you through these concepts step by step, focusing particularly on building a strong foundation for your journey into the world of web technologies. We will cover a variety of topics including front-end and back-end development, key technologies like HTML, CSS, and JavaScript, and the various libraries and frameworks available to developers today. So far, we've delved into some essential modern JavaScript features introduced in ES6, which greatly enhance our ability to develop with React.Js. We discussed arrow functions, template literals, destructuring assignment, the spread operator, classes, modules, and promises. Each of these features contributes to cleaner, more maintainable code, and understanding these will prove invaluable as we continue our exploration of React and web development. Now we will undertake a deeper examination of web development fundamentals. Now let's see how we can create a simple web page using HTML. The code begins with a declaration that defines the document type, ensuring that the browser processes it correctly. We set the language of the document to English and include character set definitions for proper text representation. Within the head section, we establish essential metadata, including the viewport settings to ensure responsiveness on different devices, and provide a title that appears in the browser tab. The body section contains the visible content. The H1 tag is used for the main heading, which welcomes visitors to the website, followed by a P tag that provides a brief introduction. Additionally, we use the tag to create a hyperlink, inviting users to visit an external site. When clicked, this interactive element facilitates navigation without the need for users to manually type in the URL. This basic structure is foundational for creating more complex web pages and demonstrates the essential elements of HTML as we begin to explore web development. Next, we will write the following CSS to enhance the style of our web page. In this example, we set the background color of the entire page to a light gray, F0, 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 providing a subtle, clean backdrop that allows the content to stand out. We also specify that the font used throughout the page should be Arial or a sans serif font, ensuring readability and a modern feel. For our main heading, H1, we choose a dark gray color, 333, which contrasts nicely against the lighter background and draws attention to the title of the page. Additionally, we set the paragraph text to have a consistent font size of 16 pixels and a line height of 1.5, which improves text legibility by giving the content enough spacing between lines. This CSS will be linked to our HTML document using a link tag in the head section. Properly linking the CSS is crucial, as it ensures that styles are applied correctly when the page loads, making the site visually appealing and organized. By implementing these styles, we create a solid foundation for the overall aesthetic of our site. Now let's take a look at how we can implement interactive behavior on our web page using JavaScript. In this code, we start by creating a button element that users can click, which is identified by the ID greet button. Below the button, we have a paragraph element with the ID greeting message, where the greeting will be displayed. Next, we use JavaScript to retrieve these elements from the DOM using the getElementById method, which allows us to manipulate them. We then add an event listener to the button that responds to the click event. This means that when the user clicks the button, the function inside the event listener is executed. Inside this function, we change the text content of the paragraph element to display a friendly greeting. Hello, welcome to my website. This illustrates how JavaScript enables us to create dynamic and engaging user experiences. By incorporating this simple script, users can interact with your site in real time, making their experience more enjoyable and interactive. Now let's see how we can implement a simple web server using Express.js, a popular framework for building web applications in Node.js. The first line of our code requires the Express module, making its functionality available to our application. We then create an instance of the Express application by calling Express, which sets up our app to handle incoming requests. Next, we define a constant port and set it to 3000, which is the port our server will listen to for incoming connections. This is a common practice that allows us to easily change the port number if needed. Following this, we specify a route for the route URL / using the app_get method. This method takes two arguments, the path of the route and a callback function that defines how to respond to requests to that path. In this case, we send back a simple text response saying "Hello World" whenever a user accesses the route URL. Finally, we call appListen with the specified port, allowing our server to start listening for incoming requests. The callback inside this method logs a message to the console, informing us that the server is running successfully and where it can be accessed. This setup serves as the foundation for building more complex APIs and web applications. Now let's see how we can fetch data from an external API using JavaScript. The code begins by calling the fetch function, which is a built-in method that allows us to make network requests and retrieve resources across the web. In this case, we are accessing data from a specified URL, which points to an API endpoint. When the request is made, it returns a promise that resolves to the response of that request. However, we need the data in a usable format. To accomplish this, we call the JSON method on the response object, which also returns a promise, this time resolving to the parsed JSON data. Once we have the data, we proceed to the next step by adding another then method where we can perform any action with this data. Here, it's simply logged to the console, allowing us to see the output directly in our developer tools. Lastly, the code includes a catch method that handles any errors that may occur during the fetching process, logging any encountered issues to the console. This structure not only helps in accessing API data effectively, but also in managing potential errors, ensuring a smoother user experience. As a closing thought for this exploration into web development fundamentals, it's vital to grasp that although you can build web applications using pure HTML, CSS, and JavaScript, adopting frameworks like React.Js can significantly reduce development time and enhance performance. These libraries offer pre-built components, state management systems, and an easier way to handle DOM manipulations and user events. They allow developers to focus on creating engaging user experiences while abstracting away many complexities. Creating a successful web application involves a mix of understanding these core technologies and learning how to integrate them effectively. As you continue this journey, keep experimenting, coding, and asking questions. Each is a stepping stone to becoming proficient in web development. Thank you for joining me in this introduction to web development fundamentals, and I look forward to helping you further in your learning process. In this tutorial, we're diving into the exciting world of modern JavaScript features, particularly focusing on ES6, which has revolutionized the way we write JavaScript today. So far, we learned about the fundamental concepts of web development, covering both front-end and back-end development. We explored essential technologies such as HTML, CSS, and JavaScript, discussing how they work together to create interactive and visually appealing web applications. Additionally, we introduced frameworks like React.Js that can streamline the development process and enhance performance. Finally, we emphasized the importance of understanding APIs for seamless communication between front-end and back-end components. Now, we will cover the modern JavaScript features that you will utilize in React.Js. First off, let's talk about ES6, also known as ECMAScript 2015. It introduced many new features that make coding more efficient and enjoyable for developers. With ES6, we have better ways to handle variables, functions, and even objects. One of the most significant changes is the introduction of the let and const keywords for variable declarations. Unlike the traditional var, which is globally scoped or function scoped, let and const provide block scoping, meaning the variable is only accessible within the block in which it is declared. Now let's take a look at how we can implement block-scoped variables using let and const. In the first example, we define a variable called greeting using let and a constant pi using const inside a block. Let allows the variable greeting to be limited in scope, so it cannot be accessed outside the block it's defined in. Attempting to log greeting or pi outside the respective block boundaries results in a reference error, emphasizing the importance of scope in maintaining variable integrity. Next, we'll see how template literals can enhance our string manipulation capabilities. By using backticks instead of traditional string concatenation, we create a full greeting variable that incorporates the first name and last name variables seamlessly. This approach not only improves readability, but also makes it easy to create multi-line strings and integrate expressions directly within the string. The example highlights the clarity and power of template literals, which make coding strings far more intuitive. Now let's implement the following code using arrow functions, a feature that streamlines our coding experience. The first function, add, takes two parameters, a and b, and uses an implicit return to deliver their sum. Notice how we've avoided curly braces and the return keyword, which enhances readability and conciseness. This is one of the key advantages of arrow functions. Next, we create the printNumbers function, which accepts an array called numbers. This function utilizes the forEach method to iterate over each number in the array and log it to the console. Here, the arrow function syntax also maintains the lexical binding of this, simplifying interaction with objects. This feature is particularly beneficial when dealing with callbacks in asynchronous code or when working within classes, as it ensures that the context remains consistent. By implementing these examples, we not only see the syntax of arrow functions in action, but also observe how they can significantly simplify our code while making it more maintainable. Now let's explore the spread operator, a powerful feature introduced in ES6 that simplifies array and object manipulation. First, we have an array called numbers containing the elements 1, 2, and 3. By using the spread operator, we create a new array called new numbers. This allows us to expand the elements of the existing numbers array while also adding 4, 5, and 6 to it seamlessly. As a result, new numbers combines all the elements into a single array without the need for tedious loops, allowing for clean and concise code. Next, we can see how the spread operator works with objects. We have an object obj1 with properties a and b. With the spread operator again, we create a new object obj2 that merges obj1 with an additional property c. This demonstrates how easily we can merge multiple objects and manage their properties in a readable way, showcasing the convenience of the spread operator in modern JavaScript development. Now let's take a look at the destructuring assignment, a powerful feature that can enhance readability and reduce the clutter in your JavaScript code. In our first example, we have an object called person that contains properties like name and age. Instead of accessing these properties individually with additional variable assignments, we can destructure them in one line, creating separate variables for name and age. This simplifies our code by directly unpacking the values from the object. Next, we see an array called colors, which contains a list of color strings. By using array destructuring, we can conveniently assign the first and second colors directly into variables first color and second color. This not only reduces the number of lines of code, but also makes it clearer what each variable represents. As you experiment with destructuring, you'll find it makes your coding experience more intuitive and your code much cleaner, allowing you to focus more on functionality than on variable management. Next, we will write the following code that leverages the map method to manipulate arrays efficiently. The map function creates a new array by applying a specific operation to each element of the original array, in this case, doubling the numbers. When we define the doubled variable we call numbers, map num equals num asterisk 2, where num represents each element in the numbers array. As a result, we generate a new array containing the doubled values, which we then log to the console. Now let's see how we can implement the filter method to extract certain elements from an array. In our example, we define an array called ages and utilize filter to generate a new array containing only those ages that are less than 21. The function checks each age and returns a new array, below 21, which holds only the qualifying values. This approach showcases how filter effectively narrows down data based on specific criteria. Finally, we will take a look at how the reduce method can be used to compute a single output from an array of values. Here, we define total and utilize reduce to sum up all elements in the numbers array. The reducer function takes two parameters, an accumulator, which stores the cumulative sum, and the current element being processed. By initializing the accumulator at 0, we can progressively add each number together, yielding the final result, which represents the total sum of the array. Now let's take a look at how to implement classes and inheritance in JavaScript. The example begins with the definition of a class called animal, which has a constructor that assigns a name to the instance. This approach allows us to create objects with a defined structure and behavior. The speak method is then defined within the animal class to output a generic noise for any animal. Next, we introduce the dog class, which extends the animal class. The extends keyword signifies that dog is a subclass that inherits properties and methods from the animal class. By overriding the speak method, we tailor the behavior specific to dogs, allowing it to provide a custom output when invoked. Finally, we create an instance of dog with the name Rex and call it speak method. This illustrates how the dog class not only inherits functionality but also enriches it, showcasing the power of object-oriented programming in JavaScript. Through this structure, we can efficiently manage and expand the capabilities of our objects, enhancing code organization and reusability in our applications. Now let's take a look at how we can manage asynchronous operations in JavaScript using promises. In the provided code, we start by creating a new promise object that accepts a function with two parameters, resolve and reject. This function simulates fetching data from an API by setting a success variable to true. If the success condition is met, we invoke resolve with a success message, indicating that data has been fetched successfully. On the other hand, if something goes wrong, which is not the case in our simulation, we would invoke reject, passing an error message. Next, we use the then method on the promise to handle the successful resolution of the operation. In this case, it logs the success message to the console. Conversely, if the promise were rejected, we would handle the error using the catch method, which allows for a graceful handling of errors without breaking the flow of the application. This approach to handling asynchronous code is much cleaner and more manageable than traditional callback functions, helping prevent the pitfalls of callback hell and ensuring your code remains readable and structured, especially as you begin working with APIs. In summary, ES6 has equipped us with a plethora of powerful tools and features that simplify coding, make it more efficient, and enhance readability. By incorporating features like let, const, template literals, arrow functions, destructuring, classes, and modern array methods, you can write cleaner and more powerful JavaScript code. As you venture further into React.Js development, understanding these modern JavaScript features will not only enhance your coding experience, but also empower you to produce more significant and scalable applications. So, gear up. In the next section, we'll dive deeper into how these concepts play a vital role in building React.Js applications. Web development is an exciting journey that transforms ideas and concepts into interactive digital experiences. Today, we are diving deep into the fundamentals of web development. So far, we have learned about essential web technologies, including HTML, CSS, and JavaScript, alongside frameworks like React.Js. Now, we'll explore how these tools function seamlessly to create dynamic and engaging web applications. Let's start with a quick recap of what we've covered so far. We looked closely at HTML, where we learned it structures our web pages by defining elements like headings, paragraphs, and images. We covered CSS, which styles these elements, providing visual appeal. Think of it as the makeup on a face. It enhances the features. Finally, we explored JavaScript, the powerhouse that adds interactivity. It allows users to engage with our web pages by responding to clicks, scrolling, and other events. Now we will dig deeper into some essential concepts necessary for building effective web applications. First, we'll clarify the difference between front-end and back-end development. If you picture a restaurant, the front end is like the dining area where customers get to see the decor, the menu, and where they interact with the staff. It's all about user experience. Conversely, the back end is the kitchen where all the magic happens, albeit out of sight. It manages the database, the server, and the business logic, everything that supports the front end without being visible. For example, when using an app like YouTube, the front end displays a grid of videos. A user can click to watch their favorite content. However, behind the scenes, the back-end algorithms decide which videos to show based on user behavior and preferences. Understanding this division will help you appreciate how a well-structured web application operates. Now let's see how we can implement a simple React component to illustrate the integration of HTML, CSS, and JavaScript. In this example, we define a functional component called greeting. Within the component, we use JSX, a syntax extension for JavaScript that resembles HTML, allowing us to define the component's structure visually. The component returns a div element with inline styles applied for text alignment, demonstrating how we can manipulate the appearance of elements dynamically. Inside the div, we have an H1 heading styled to be blue, conveying a welcoming message to users. Alongside it, a paragraph provides additional context about the component itself, creating a simple yet effective user interface. By exporting greeting as the default, we enable its use in other parts of our application. This snippet epitomizes the power of React, seamlessly combining JavaScript logic, HTML structure, and CSS styling to create an interactive component that enhances user engagement in web applications. Now let's take a look at how variable scoping works in JavaScript through a practical example. We have a function named testScope that illustrates differences between var, let, and const. Initially, we declare three variables. X is defined using var, while y and z are declared with let and const, respectively. The key distinction here is that var is function scoped, meaning it can be accessed anywhere within the function, while let and const are block scoped, limiting their accessibility to the block in which they are declared. Inside an if block, we overwrite the x variable declared with var without creating a new instance, resulting in x being 50 throughout the function. In contrast, the y variable declared with let inside the same block is a separate instance from the y outside the block, so it retains its value of 20. The const variable z, being outside the block, remains unaffected and retains its value of 30. This example effectively demonstrates how using let and const leads to better variable management practices, which is crucial for maintaining clean and understandable code as projects scale. Now let's take a look at how arrow functions can enhance our JavaScript code. In the snippet, we define a function named multiply using the arrow function syntax. Arrow functions allow for a concise way to write function expressions, reducing boilerplate code and improving readability. Instead of using the traditional function, keyword, and curly braces, we directly assign the function to a constant variable. The multiply function takes two parameters, a and b, and returns their product in a single expression. This streamlined approach means that if the function consists of only one expression, we can omit the curly braces and the return statement entirely. When we call console log multiply 5, 4, it outputs the result of the multiplication, which in this case is 20. This demonstrates not only the power of arrow functions in creating shorter and clearer function definitions, but also their capability for handling computations efficiently. Such syntax improvements are part of what makes ES6 a significant evolution in JavaScript, enhancing both developer productivity and code maintainability. Next, we will explore how template literals in JavaScript enhance our string manipulation capabilities. In the following example, we begin by declaring a variable username and assigning it the value Alice. This sets the stage for greater flexibility in our string formatting. Now, let's look at how we can implement template literals using backticks instead of traditional quotation marks. By employing backticks, we can easily create multi-line strings and seamlessly embed variables within our strings. In the line where we define the greeting variable, notice how we use username to inject the value of the username variable into our string. This eliminates the need for cumbersome concatenation, making our code cleaner and easier to read. When we invoke console log greeting, it outputs a friendly greeting that includes the user's name, demonstrating how template literals improve both code readability and functionality. This simplification in string handling is particularly valuable when creating dynamic messages or multi-line outputs, making our development process more efficient. Now let's dive into the array methods that ES6 introduced, starting with map. In the following example, we take an array of numbers and use the map method to create a new array where each number is multiplied by 2. This showcases how powerful and succinct JavaScript can be, allowing us to transform data effortlessly. With map, the original array remains unchanged, and the operation returns a new array containing the modified values. This emphasizes the functional programming style that ES6 promotes, leading to cleaner and more readable code. Next, we will take a look at the filter method, which helps us create a new array consisting only of elements that satisfy a specified condition. In this case, we focus on an array of ages and use filter to isolate only those that are 18 or older. This method excels at removing unwanted values, thereby enriching our data by retaining only those entries that meet our criteria. The beauty of filter lies in its intention to match conditions, which can be particularly useful in data processing scenarios where we need to clean or refine our datasets. Now let's implement the following example using the reduce method to calculate the total score from an array of numbers. In this code, we define a constant array named scores, which contains 4 integers, 10, 20, 30, and 40. Our goal is to sum these values efficiently using the reduce method. The reduce function takes 2 parameters, a callback function and an initial value for the accumulator, which in this case is set to 0. The callback function itself has 2 parameters, accumulator and score. As reduce iterates over each element in the scores array, it adds the current score to the accumulator, gradually accumulating the total score. This functional approach not only keeps the code concise but also enhances readability, making the logic clear at a glance. Finally, we log the total score to the console, which displays the cumulative sum of all the scores, resulting in 100. This effective use of reduce demonstrates how we can streamline our data manipulation in JavaScript, offering a powerful tool for developers. In summary, we have covered the critical aspects of web development fundamentals. From understanding the role of HTML, CSS, and JavaScript in creating engaging web applications, to exploring modern JavaScript features, we have gained valuable insights into how they enhance our coding practices. As we move forward, we will apply these concepts to develop more complex applications using React.Js and gain hands-on experience that brings our coding skills to the next level. This journey promises to be informative and exciting. Stay tuned for the next. Now let's delve into how variable scoping works using both var, let, and const in JavaScript. In this example, we have a function named example function. Inside this function, we declare three variables, x, y, and z. The variable x is declared using var, making it function scoped, while y and z are declared with let and const, respectively, which are block scoped. As we progress into the if statement, notice how var x is reassigned within this block. This action overwrites the value of x throughout the entire function due to its function scope. In contrast, when we declare let y within the if block, it creates a new block-scoped variable that does not affect the outer variable y. The logs show this distinction clearly, where the global x reflects the reassigned value while y retains its original value. Finally, const z remains unchanged throughout the function since it cannot be reassigned. Understanding these scope differences is crucial as they help prevent bugs when managing state and props in components. By utilizing let and const effectively, we can write cleaner and more predictable code, particularly in the context of React applications. Now let's take a look at how we can structure a simple React component using modern JavaScript syntax. In this example, we define a functional component called greeting. Within this component, we declare a constant named message using the const keyword, which ensures that this variable remains unchanged throughout the component's lifecycle. This practice is essential for maintainability, as it helps prevent accidental reassignment and keeps our code predictable. The value of message is a string that welcomes users to the world of modern JavaScript with React. This demonstrates how we can easily manage data within our components. The component returns a JSX element, specifically an h1 tag, where the content of the message variable is displayed dynamically. This seamless integration of JavaScript expressions within JSX highlights the power of React in building interactive user interfaces. Using const for our constants is a best practice that emphasizes clarity and helps avoid bugs in more extensive applications where different components may interact with shared data. Thus, adopting const not only simplifies our code, but also enhances our programming discipline as we develop more complex React applications. Now let's take a look at the arrow function syntax in action. The code begins with a simple arrow function called sum, which takes two parameters, a and b, and returns their sum. This concise form improves readability and reduces boilerplate code compared to traditional function declarations. Next, we see the implementation of a counter class component in React. Here, the constructor initializes the component state with a count set to 0. To handle the increment action, we define an arrow function named increment that utilizes setState to update the count, leveraging the previous state to ensure accuracy. The beauty of using an arrow function here is that it automatically binds this to the component instance, which eliminates the need for binding in the constructor, a common source of errors in traditional React components. In the render method, we return a simple UI that displays the current count and a button. When the button is clicked, it triggers the increment function, incrementing the count displayed on the screen. This example illustrates how arrow functions simplify syntax and elegantly manage scope in React components, promoting better coding practices. Now let's take a look at how we can render personalized greeting using template literals in a React functional component. The user greeting component accepts a username prop, which represents the name of the user. Inside the component, we return an h1 element that utilizes template literals, demonstrated by the backticks to dynamically insert the username into the greeting message. This approach enhances code readability and eliminates the need for cumbersome string concatenation, typically done with the plus operator. By embedding the variable directly within the template string, we can create a more fluid and expressive way to generate content. This feature is particularly valuable in React when we often need to display dynamic data. Overall, using template literals not only simplifies the code, but also allows for multi-line string rendering, making it a powerful tool for developing user-friendly applications. Now let's see how we can dynamically render a list of users using the map method. In the provided code, we have an array of usernames, which includes Alice, Bob, and Charlie. The userList functional component utilizes the map function to iterate over this array. For each user, it generates an lie element representing a list item that displays the user's name. This is done within an unordered list all, making it clear that the names are part of a list. It's important to note that when rendering lists in React, each item should have a unique key prop. In this case, we use the user's name as the key, ensuring that React can efficiently track each list item during re-renders. By adopting the map method, we transform our array of usernames into a series of list items in a seamless and efficient manner, showcasing the power of ES6 array methods in constructing dynamic UIs. This not only simplifies the code, but also enhances readability and maintainability, which are essential in React development. Next, we will write a simple React component to display only the completed tasks from a predefined list. First, we define an array of tasks that contain properties such as ID, task, and completed. Each task object indicates whether it has been completed or not. Moving forward, we create a functional component named completed tasks. Inside this component, we utilize the filter method to generate a new array that exclusively includes tasks marked as completed. This approach highlights the filter method's ability to streamline our code by reducing complexity while focusing on functionality. In our return statement, we then iterate over the completed tasks array using the map method to render each completed task inside an unordered list, all. Each task is displayed as a list item, lie, ensuring that each item has a unique key property corresponding to the task's id. This method of filtering and mapping not only keeps our code clean and organized, but also enhances readability and maintainability, key principles in developing React applications. Now let's take a look at how we can effectively count completed tasks using the reduce method. In this example, we define a constant called completed count, which utilizes reduce to iterate through the tasks array. The callback function takes two parameters, count, which keeps track of the total number of completed tasks, and task, which represents the current task being processed. Within the callback, we check if the completed property of the task is true. If it is, we increment the count by 1, otherwise we return the count unchanged. This concise logic allows us to accumulate the total count of completed tasks efficiently in a single value. Next, we can see how this accumulated value is used within a functional component named total completed tasks. Here, we render a heading that displays the total number of completed tasks, utilizing the completed count constant to provide dynamic output. This approach illustrates not only the power of the reduce method for aggregating data, but also how we can leverage this accumulated data to provide meaningful insights in our React application. By understanding and applying such techniques, we enhance our ability to manage and present data effectively in our projects. Now let's take a look at how we can utilize destructuring in a React component to efficiently manage props. In the user profile component, we're destructuring the user object directly in the function parameters, extracting properties like name, age, and email. This technique not only enhances code readability, but also simplifies the way we access these properties within our component. By doing so, we avoid repetitive code and the need for additional variable declarations throughout the function. The component returns a simple JSX structure that displays the user's information. Each property extracted from the user object is dynamically injected into the HTML elements, allowing for a clean presentation. This method of destructuring is especially handy when dealing with multiple properties, making it clear which data is being used from the props. This approach also sets a standard for coding practices in React, promoting a tidy syntax and cleaner state management in larger applications. By embracing such patterns, developers can maintain focus on the application's logic rather than getting bogged down by verbose code structures. Now let's see how we can implement a feature for updating a list of users using the spread operator. In our example, we start by defining a new user object that includes an ID, name, and age. This user can be added to an existing list of users without modifying the original array, which is crucial for maintaining immutability in React. We utilize the spread operator to create a new array that merges the existing users with the new user. By doing so, we ensure that the original users array remains unchanged, thereby adhering to React's best practices regarding state management. After defining this updated list, we can create a React functional component named userList. Within this component, we return a list of users by mapping over the updated users array. Each user is displayed within a list item, where we assign a unique key derived from the user's ID. Using the spread operator and React's render method in this way enhances both performance and predictability in our application, as it allows for efficient state updates and a clear representation of lists in the user interface. Now let's implement a component that demonstrates how to fetch and display user data from an API. First, we import the necessary React hooks, useEffect for side effects and useState for managing local state. We define a functional component called userFetcher, where we initialize a state variable users, which will hold our fetched user data. Within this component, we create an asynchronous function named fetchUsers. This function uses the fetch API to retrieve data from a given URL. We await the response, convert it to JSON format, and then update our user's state with the retrieved data. To ensure this data fetching occurs when the component mounts, we leverage the useEffect hook. By providing an empty dependency array, we guarantee that fetchUsers executes only once, right after the initial render. Finally, we return a list of user names from the user's state, mapping over each user to create a list item. This encapsulates the data fetching pattern in React, showcasing how a sync-await syntax simplifies working with asynchronous operations and enhances code readability within the component. Now we have covered a variety of modern JavaScript features that benefit React applications, from variable scoping with let and const to the elegance of arrow functions, template literals, and concise methods for handling arrays. By employing destructuring, the spread operator, and a sync-await, we can write code that is cleaner and often less error-prone. As we continue to explore these features, our aim is to combine them to build robust, interactive applications that provide an excellent user experience. The future modules will focus on implementing these concepts in full-fledged projects to put our newfound skills to the test. This is where the magic of React development shines, taking our simple scripts to the next level of sophistication and performance. So gear up, as we have a lot more exciting coding. In this video, we're diving into an exciting journey of web development. This foundational area is not only crucial for creating dynamic websites, but also for grasping how digital aesthetics and functionality come to life on our screens. So far, we learned about the significance of ES6 in enhancing JavaScript, particularly for React.Js applications. We explored foundational web development elements, the importance of variable scoping, and modern JavaScript features such as arrow functions, template literals, and array methods. We also highlighted how these features contribute to cleaner, more maintainable code while developing robust React applications. As we move forward, we will continue to integrate these concepts into practical projects. Now let's write a simple HTML structure for our web page. The first line of the code declares the document type as HTML, which helps browsers understand how to render the content properly. We then open the HTML tag, marking the beginning of our HTML document, followed by a head section that contains meta information about the web page, including the title that appears in the browser tab. Next, we move to the body section, where we can add the visible content of our page. We include a level 1 heading with the h1 tag that welcomes users to our website, establishing a clear title for anyone visiting. Below that, we add a paragraph using the p tag to share more information about the site, providing context for readers. Lastly, we add a button element that users can interact with. This is crucial as it engages users and invites them to take action. This basic structure not only organizes content, but also establishes a foundation for further interaction and styling, as we'll enhance it with CSS and JavaScript in the following sections. Now let's see how we can style our previously written HTML code using CSS. In this snippet, we begin by applying a light blue background color to the entire body of our web page, creating a calming and visually appealing atmosphere for users. Additionally, we specify the font family as Arial, which is a widely used sans serif font, ensuring the text is easy to read. Next, we define the styles for our heading by changing its color to dark blue, which provides a nice contrast against the light blue background. This makes the heading stand out and captures the viewer's attention effectively. Now let's implement styles for the button element. We set its background color to white and add a solid dark blue border for a crisp finish. The text color of the button is also dark blue, ensuring consistency across the page. To enhance user interaction, we include padding for better spacing within the button and specify a font size of 16 pixels. These styling choices significantly improve the button's appearance and usability, making it inviting for users to click. Overall, with just a few lines of CSS, we effectively enhance the visual aspects of our web page. Now let's see how we can add interactivity to our web application using JavaScript. The first step is to select the button element present in our HTML. We achieve this by using the document query selector method, which allows us to easily find the button in the DOM. Once we have selected the button, we need to attach an event listener that listens for user interactions, in this case, a click event. By using the addEventListener method, we can specify that when the button is clicked, we want to execute a certain function. Here, we define a simple function that triggers an alert, which will notify the user that the button was clicked. This approach illustrates the power of JavaScript in creating dynamic web experiences. By implementing event listeners, we can respond to user inputs and manage the web page's behavior in real time. This simple example is just the beginning. As you become more comfortable with JavaScript, you'll explore more advanced techniques like manipulating the DOM, making AJAX calls, and handling various user events effectively. Now that we've set the stage with HTML, CSS, and JavaScript, let's differentiate between front-end and back-end development. The front end is what users see and interact with in their browsers. It includes everything visible: the layout, the design, the buttons, and the navigation. Front-end development focuses primarily on user experience and what their visual representation will look like. On the contrary, the back-end is the server side that users cannot see. It powers the front end by managing databases, server logic, and API communications. A simple analogy would be comparing a website to an iceberg. While only a small portion is visible above the water, a much larger mass lies below, doing all the heavy lifting. Technologies commonly found in backend development include Node, JS, Express, Django, and Ruby on Rails, among others. Now let's take a look at how we can create a simple React component to deliver personalized messages to users. We will define a greeting component that takes in props, specifically a name property. This component utilizes JSX, which allows us to write HTML-like syntax directly within our JavaScript code. In our greeting function, we return an h1 element that incorporates the name prop, generating a dynamic greeting. By placing prop's name within the curly braces, React allows us to embed JavaScript expressions inside the returned JSX. This capability showcases the power of React's component-based architecture. We can create one greeting component and reuse it throughout our application with different names, enhancing our application's efficiency and organization. Thus, each time we utilize this greeting component, we can easily pass a different value for name, resulting in a personalized greeting for each user. This approach not only streamlines our development process, but also promotes a clean, maintainable code structure, essential for building complex applications. Now let's see how we can simplify our function declarations using modern JavaScript syntax. Traditionally, we would declare a function using the function keyword, which can feel verbose, especially as our code base grows. For example, when we write a standard function to add two numbers, the syntax looks quite detailed, defining a function named add that takes two parameters and returns their sum. Now let's implement a more concise approach with arrow functions. By using the arrow function syntax, we define the same add functionality in a much cleaner way. Instead of writing the function keyword, we directly use the arrow syntax, followed by the parameters in parentheses, and then the expression to return. This not only reduces the lines of code, but also enhances readability, making it easier for others to understand what our function does at a glance. This simplified syntax is particularly advantageous in collaborative environments and larger projects where clarity and maintainability are key. Embracing these ES6 features empowers us to write cleaner, more efficient code that aligns well with modern JavaScript practices. Now let's see how we can implement state management in a simple form using React. In this example, we define a functional component called userForm. We start by importing the necessary React functionalities, specifically the useState hook, which allows us to manage state within our component. Inside the userForm function, we create a state variable called name, initialized to an empty string, and a function setName to update the state value. This is where we begin to capture user input. Next, we define the handleSubmit function, which is executed when the form is submitted. This function prevents the default page reload using event_prevent_default and logs the current name to the console. This approach allows us to demonstrate how to handle form submissions without refreshing the page. In the return statement, we create a form element with an input field and a submit button. The input field has an onChange event that calls setName, updating the state as the user types. This dynamic interaction is essential, as it enables React to re-render the component based on user input, providing a responsive user experience. To conclude, understanding web development's fundamental concepts such as HTML, CSS, JavaScript, and the distinctions between front-end and back-end lays your foundation for becoming a proficient developer. By integrating libraries like React.Js and leveraging modern JavaScript features, you empower yourself to build flexible, scalable, and interactive applications. In our next videos, we will delve deeper into these technologies, get more hands-on with React, explore JSX, and discover how to build dynamic user interfaces. So buckle up for an exciting ride ahead. Happy JavaScript has evolved significantly over the years, with many versions enhancing the language's capabilities. ES6 or ECMAScript 2015 brought a treasure trove of new features that make it easier to write clean and efficient code, especially when working with React.Js. So far, we learned about the fundamentals of web development, including HTML, CSS, and JavaScript, which are essential for creating the structure, style, and interactivity of websites. We explored the differences between front-end and back-end development, along with the importance of state management in React applications. Additionally, we discussed modern JavaScript features from ES6 that enhance code readability and efficiency. Moving forward, we will dive deeper into the specific ES6 features that will empower our React applications and improve our overall coding experience. Now let's take a look at a simple React component that demonstrates the use of the *const** keyword for defining a constant variable. In this code, we define a functional component named *myComponent*, where the constant *greeting is initialized with the string hello world. Since the value of *greeting is not expected to change during the execution of this component, we use *const** for its declaration. This ensures that we have a clear intention about the variable's immutability, promoting better code stability. Next, we will implement another component called *counter* that showcases the use of the *let** keyword. Here, *let* allows us to create a variable named *count*, which is initialized to 0. This variable is intended to change as the user interacts with the component. The function *increment count* is defined to increment the value of *count each time the button is clicked, showcasing how *let** facilitates dynamic updates. By using these variable declarations appropriately, we leverage JavaScript's ES6 features to write more efficient and maintainable React code. Now let's see how we can define methods in a class component using traditional syntax. In the first example, we create a React component that initializes state in the constructor. The method handleClick is defined as a normal function, which requires us to explicitly bind it to the component instance. This binding is necessary to ensure that this refers to the correct context when the method is called. As a result, if we click the button rendered in the render method, it will successfully alert the user with a greeting that includes the name stored in the state. Now let's see how we can implement this using arrow functions, which provide a more modern and cleaner approach. In the second example, the handleClick method is defined as an arrow function, allowing us to avoid the binding altogether. With this syntax, this is lexically bound, meaning it retains the context of the surrounding code, making our component easier to read and reducing the chances of errors associated with bindings. This showcases the power of ES6 features in enhancing the efficiency and readability of our React components, simplifying state and props access. Now let's explore how template literals can enhance our code's clarity and functionality. In the first example, we declare a constant variable called name and assign it the value Jane. Using backticks, we create a greeting string that incorporates the variable name seamlessly. This use of a template literal allows for dynamic string creation, so when we log the greeting to the console, it outputs a friendly message. Hello Jane, welcome to React. Next, we will implement a functional component called userProfile that demonstrates the power of template literals in a React application. Here, we receive a user object as a prop. Within the component's return statement, we construct a user interface that displays the username and email using template literals to interpolate the respective properties from the user object. The syntax inside curly braces allows us to include JavaScript expressions directly within the JSX, facilitating a clean integration of dynamic data within our component. This approach not only improves readability, but also minimizes potential errors, making it an invaluable tool for React developers. Now let's take a look at how we can effectively use the ES6 spread operator for managing arrays in our React applications. In the first example, we start with an existing array of names. By utilizing the spread operator, denoted by the ellipsis, we can create a new array called *** new names that includes all the original names and appends Smith at the end. This approach helps in maintaining immutability, which is critically important in React to avoid unexpected side effects when updating state. Next, we explore state management with the useState hook in React. Here, we define a userState object that has a name and age. To update the age without directly mutating the original user object, we again use the spread operator. This allows us to create a new object that retains all existing properties of the user while updating the age. Such practices are vital in React to ensure that the component re-renders correctly whenever state is altered, ultimately leading to a smoother user experience. By adhering to these principles, you are laying the groundwork for clean and efficient React code. Now let's see how we can implement destructuring in our React components to improve code clarity and efficiency. In the first example, we define a functional component that receives props as an argument and accesses the title property using props title. This works, but it can lead to repetitive code if we need to access multiple properties. To streamline this, we can use destructuring by extracting the title directly from the props in the component's parameter. This not only reduces the amount of code we write, but also makes it immediately clear which properties we are working with. Next, we'll explore a functional component that handles user data. Here, we initialize a state variable called user using the useState hook, which contains both the username and email. Instead of repeatedly accessing these properties from the user object, we can destructure them right away. This allows for a cleaner return statement and enhances readability by laying out the data we want to display more explicitly. Through these examples, we see that destructuring not only cleans up our code, but also establishes a clearer connection between our data and how it's used in the rendered output. Now let's implement a component using CSS Modules. In the user_profile.js file, we define a functional component named userProfile. This component serves as a structure for displaying user-related information, but it can be expanded with logic as needed. By adding the export keyword before the component definition, we allow this component to be accessible from other files. This approach ensures our code remains modular and maintains a clear separation of concerns. Next, we need to utilize the userProfile component in another part of our application. We accomplish this by importing it in the desired file using the import statement, specifying the path to userProfile. This modular system fosters code reusability and keeps our application organized, particularly beneficial when dealing with larger applications where components can grow in complexity. Additionally, let's explore how we can structure helper functions in another file, userUtilities.js. Here we define two named exports, getName and getEmail. These functions retrieve user properties, allowing us to utilize them as needed without loading the entire module, which optimizes performance and keeps our component files concise and focused. Now let's see how we can implement a function that simulates fetching data in a React application using promises. The fetchData function is designed to return a new promise, which allows us to handle asynchronous operations gracefully. Inside the promise, we use the setTimeout method to mimic an API call that resolves after a 2-second delay, providing a mock user data object with a name and age. Next, we'll create a functional component named myComponent, which will leverage the useState hook to manage user data state. Here we define an asynchronous function, fetchUserData, where we invoke fetchData with the await keyword. This pauses the execution until the promise is resolved, ensuring that we get the user data before proceeding. When the data is received, it updates the state using setUser. Finally, we utilize the useEffect hook to call fetchUserData when the component mounts. This approach allows us to fetch the user data right away. The rendered output conditionally displays the user's name once the data is available or a loading message until it finishes fetching, demonstrating a clean and readable way to handle asynchronous data in a React component. As we've traversed the landscape of modern JavaScript for React.Js, we've seen that embracing ES6 features like let and const, arrow functions, template literals, the spread operator, destructuring modules, and async await transforms our coding experience. These features empower us not only to write cleaner and more efficient code, but also help us manage state and props effectively in React applications. Armed with these tools, we can create components that are not only dynamic and functional, but also easier to maintain and understand. As we dive deeper into our React learning journey in future lessons, we'll implement these features to build robust and responsive applications that can handle the demands of modern web development. So keep your coding spirit high, and let's get ready to put these concepts into practice. Happy coding! In this video, we will dive into the exciting world of web development fundamentals. By the end of this lesson, you will grasp the essential concepts that form the backbone of building modern web applications. So far, we've learned about the evolution of JavaScript and its enhancements through ES6, focusing on features that empower us to write efficient code for dynamic applications. Now we will cover the fundamental technologies you need to know: HTML, CSS, and JavaScript. Web development is broadly categorized into two main areas: front-end and back-end development. Let's highlight what sets these two realms apart. The front end is everything that a user interacts with directly: the layout, buttons, text, images, and overall design. Essentially, it's the user interface. On the other hand, the back end is the server-side component of the application that handles data storage, processing, and communication with the client-side application. To visualize, think of a restaurant. The front end is the dining area where customers enjoy their meals, while the back end is like the kitchen where all the food is prepared. Now let's get into the technologies that you will use to develop the front end of web applications. The three core technologies are HTML, CSS, and JavaScript. Each one serves a distinct purpose. HTML, or hypertext markup language, provides the structure of the web page. It consists of elements like headings, paragraphs, images, links, and more. CSS, or cascading style sheets, is responsible for the presentation aspect, allowing you to style your HTML elements. This includes setting colors, fonts, spacing, and layout. Lastly, JavaScript brings the web page to life by adding interactivity. For example, it can respond to user actions like clicks or key presses and manipulate HTML CSS dynamically. Now let's see how we can create a complete basic HTML document to structure our web page. The first line of the code defines the document type as HTML, which helps browsers understand how to render the page correctly. Next, we have the HTML tag that wraps the entire content of the document. Within this, we include a head section where essential metadata, such as character encoding and viewport settings for responsive design, are specified. The title of the web page, My First Web Page, is set here, which will appear in the Browser tab when the web page is loaded. Moving into the body section, this is where the visible content of our page resides. We start with an H1 tag to define a prominent heading that welcomes visitors to our web page. Below the heading, we use a P tag to include a simple paragraph that describes the purpose of the content on the page. This code exemplifies how HTML is structured. It is intuitive and semantic, making it easy for both developers and browsers to read, ensuring that your web page is well organized and user-friendly. Now let's implement some CSS styles in our HTML document. By adding a style tag within the head section, we can define how our HTML elements should be displayed. First, we set the body of the web page to have a light blue background color, giving it a refreshing and visually appealing look. We also specify the font family for the text, choosing Arial and sans serif as fallbacks, ensuring that our content is legible and clean. Next, we focus on the heading H1. We make it navy-colored and center-line it on the page. This approach draws attention to the title, making it prominent for viewers. Lastly, we style our paragraph text, P, with a dark green color. This adds contrast against the light blue background, enhancing readability while maintaining a cohesive color scheme. Through these CSS definitions, we not only improve the aesthetics of our web page, but also enhance the overall user experience by ensuring that the content is easy to read and visually engaging. This is a fundamental skill in web development, as styling directly impacts how users perceive and interact with content online. Now let's see how we can implement a simple interactive feature using JavaScript. In this example, we are creating a small web page with a heading and a button that responds to user interaction. The HTML structure begins with a standard declaration, setting the language to English. Inside the body, we define an H1 element with an ID of greeting, initially displaying the text hello. This will be the element we target for our dynamic updates. Next, we introduce a button that, when clicked, triggers a JavaScript function named changeText. This function is defined within a script tag at the bottom of our document. The function uses the document getElementById method to access our heading by its ID and changes its inner HTML to hello JavaScript. This is a fundamental demonstration of how JavaScript can manipulate HTML elements in real time, enhancing user engagement. By showcasing this simple interaction, we emphasize JavaScript's ability to bring web pages to life, creating a more dynamic and responsive experience for users. Now let's take a look at a straightforward example of creating a component in React. In this code snippet, we define a function called greeting. This function utilizes React syntax to return a simple h1 HTML element that displays the message, "Hello, React." What makes this code powerful is React's component-based architecture, which allows developers to break their application into reusable pieces. By defining our UI as components, we can independently manage and modify each part of our application, thereby enhancing maintainability. Next, we export the greeting component, making it available for use in other parts of our application. This exportation is crucial, as it allows us to import this component wherever we need to showcase the greeting message. As applications grow in complexity, component reusability becomes essential. Using components like greeting ensures that our code remains organized and efficient, aligning perfectly with modern web development practices. Next, let's explore the concept of a three-tier web application architecture. This involves separating the application into three layers: the presentation layer, the application layer, and the data layer. The presentation layer handles everything the user sees and interacts with, which corresponds directly to front-end technologies like HTML, CSS, and JavaScript. The application layer processes user requests, applies business logic, and communicates with the data layer using APIs. Finally, the data layer is where all the data is stored, usually within a database system. Each of these layers works seamlessly together to create a cohesive and efficient web application. Now let's see how we can implement a simple example of using the map method in JavaScript to transform an array of user objects into an array of user names. In the code, we start by defining an array called users, which contains 3 objects. Each object represents a user with a name and an age. The map method is then called on this array. The primary purpose of map is to create a new array by applying a specific function to each element of the original array. In this case, we provide an arrow function, user equals username, to map. This function takes each user object and extracts the name property, effectively transforming the array of user objects into a new array that contains only the names of the users. Finally, we log the usernames array to the console, which will display John, Jane, Bob. This concise example showcases the power of modern JavaScript array methods, enabling us to manipulate data collections efficiently and with minimal code. To summarize, we have laid the groundwork for understanding web development fundamentals. We discussed the difference between front-end and back-end development and explored the essential technologies, HTML, CSS, and JavaScript. We also touched on the importance of frameworks and libraries like React in building modern web applications. So far, we covered the evolution of JavaScript, its core features, and how these enable us to write clean, efficient code. As we advance, we will dive deeper into React.Js and how to craft dynamic user interfaces effectively. The world of web development is vast and ever-changing, but understanding these fundamentals will equip you with a strong foundation to build upon. Stay tuned as we continue our journey into the dynamic realm of React and web application development. Now let's dive into the exciting world of modern JavaScript features, specifically tailored for React.Js. JavaScript has had many versions over the years, and ES6 is one of the most significant upgrades that introduced a plethora of new features, enhancing both the performance and usability of the language. So far, we have learned about the fundamentals of web development, including the distinction between front-end and back-end development and the essential technologies, HTML, CSS, and JavaScript. We explored how HTML structures content, CSS styles it, and JavaScript adds interactivity to web pages. Additionally, we discussed the role of frameworks like React in enhancing development workflows and the importance of modern JavaScript features. As we proceed, we will delve deeper into how ES6 features can simplify and elevate our React development experience. Now let's take a look at a simple React component that demonstrates the use of both traditional function expressions and arrow functions in handling events. In this component, we define a state variable count to keep track of the number of clicks on the buttons. The handle traditional click method, which is a traditional function, requires us to explicitly bind this to ensure it refers to the component instance when the button is clicked. This is a common source of confusion in JavaScript because the context can change depending on how the function is invoked. On the other hand, we have the handle arrow click method defined as an arrow function. This syntax allows it to automatically inherit the context of this from its surrounding scope, which simplifies the code and eliminates the need for manual binding. In the render method, we have two buttons that trigger these click handlers. When the traditional click button is pressed, the traditional method updates the count, while the arrow click button invokes the arrow function to achieve the same. This comparison clearly illustrates why arrow functions are often favored in React development for their cleaner syntax and ease of use in event handling. Now let's see how we can implement a simple React component using template literals. In this example, we create a greeting class that extends React component. Within the render method, we define a constant called name and assign it the value world. This demonstrates the concept of variables in our component. Next, we utilize template literals to construct a greeting message inside the rendered h1 element. By using backticks and embedding the name variable directly within the string using name, we can create a dynamic greeting that is both clean and easy to read. This approach eliminates the need for cumbersome string concatenation with the plus operator, enhancing code clarity and maintainability. With this implementation, we can quickly modify the name variable and see how the rendered output adapts, allowing for easy customization of our component. This feature is particularly valuable in React development, where rendering dynamic content based on state or props is a common requirement. Thus, template literals serve as an efficient and powerful tool in our JavaScript toolkit for building interactive user interfaces. Now let's explore how destructuring assignments streamline code in React components. First, we have a functional component named userProfile, where we destructure its props directly in the function parameters. This approach allows us to access the name and age properties without needing to reference props directly, leading to cleaner and more concise code. Next, we shift to a class component called user. In the constructor, we initialize the state with name and age. Inside the render method, we apply destructuring again to extract these state properties. This practice not only enhances readability but also simplifies the code, making it easier to manage. By directly accessing name and age, we can seamlessly render them in the return JSX without extra references. This efficient method of handling props and state using destructuring is vital in React, reducing boilerplate and making our components more intuitive and maintainable. These examples illustrate the practical benefits of using destructuring, especially as our applications grow in complexity and size, demonstrating its significance in modern JavaScript and React development. Now let's take a look at the practical application of the spread operator and how it enhances the functionality of our React components. In this example, we create a custom button component that utilizes the spread operator to merge default properties with incoming props. By setting up default props to establish baseline values for the button's color and size, we ensure that our button renders consistently by default. Next, we use the spread syntax to combine default props with any additional props passed during the component's usage. This technique allows us to extract color and size seamlessly, enabling the component to automatically adopt any custom settings while still maintaining sensible defaults. This strategy promotes code reusability and clarity, as it eliminates the need for verbose prop declarations. Now let's see how we can implement a flexible list component that leverages the REST operator to handle a variable number of props. By destructuring items from the props and collecting any remaining attributes into REST, we can dynamically assign additional properties to the all element. This approach not only enhances the component's adaptability, but also simplifies the way we pass down props, ensuring that our components remain clean and functional. Now let's dive deeper into how to structure our React components using CSS Modules. First, we create a new component called header, which consists of a simple function that returns a heading element. This component is defined in its own file, header.js, and it is exported as the default export of the module. This practice of defining components in separate files promotes modularity, making it easier to manage and maintain our code. Next, we will import the header component into our main application file. We begin by importing React itself, followed by our header component using the appropriate relative path. In the app component, we utilize the header by including it within the JSX structure, allowing us to render the heading at the top of our application. This approach not only modularizes our components, but also improves code readability and collaboration among team members. By separating concerns and ensuring each component has a specific role, we facilitate easier updates and troubleshooting in our React applications. Now let's implement a component that demonstrates how to fetch data from an API using async await in React. We begin by creating a data fetcher class component that manages its own state, where we define a data property, initially set to null, and a loading property set to true to indicate that data is being fetched. Next, we utilize the component didMount lifecycle method to make an asynchronous HTTP request as soon as the component mounts. This is where the power of async await shines. We initiate a fetch request to a sample API and await its response before parsing the data as JSON. By using await, we write code that reads sequentially and handles asynchronous operations cleanly, improving readability. Once the data is fetched and parsed, we update the component's state to store the received data and set the loading state to false, signaling that the fetch operation is complete. In the render method, we check the loading state. If true, we display a loading message. If false, we map over the fetched data to create a list of posts, displaying the title of each post. This approach not only simplifies asynchronous data fetching, but also enhances error handling and overall code clarity. Now let's take a look at how we can use optional chaining and nullish coalescing in our code. In the first example, we create a user object that contains a name and an address with a city. By using optional chaining, we can safely attempt to access the city property through user address city, which returns Wonderland. This approach prevents potential runtime errors that could occur if we tried to access a property on an undefined object like user contact phone, which safely returns undefined without crashing the program. Next, we introduce nullish coalescing, which empowers us to set default values elegantly. In our code, we assign username with the expression username guest. Here, if username is null or undefined, username will be set to guest. This method streamlines the process of providing fallbacks, making our code clearer and more intentional. Utilizing these features helps manage complex structures and enhance code reliability, which is particularly useful in modern applications where handling dynamic data is essential. In summary, modern JavaScript features introduced in ES6 and beyond have radically transformed how we write React applications. We explored the power of arrow functions, template literals, destructuring, spread rest operators, modules, async await, and the benefits of optional chaining and nullish coalescing. Each of these features enhances our ability to create cleaner, more maintainable, and efficient code. As we embrace these tools, we'll find ourselves equipped to tackle complex problems with greater ease, leading to more dynamic and engaging user experiences. So, get ready to take your React skills to the next level as we dive deeper into crafting interactive components and building robust applications. Let's keep building and Web development is an exciting journey, and today we are diving into its fundamental concepts. So far, we've learned about modern JavaScript features that are essential when working with React.Js. This includes arrow functions for cleaner code, template literals for easier string interpolation, destructuring for simpler variable assignment, and the spread rest operators for manipulating arrays and objects. We also discussed how modules enhance code organization and the async await syntax that simplifies handling asynchronous operations. Each of these elements helps to improve the clarity, maintainability, and efficiency of our code as we build dynamic web applications. Now we will explore the broader landscape of web development, beginning with the fundamental technologies, HTML, CSS, and JavaScript. These three are the building blocks of any web application. Now let's take a look at how we can create a simple web page using HTML. The first line of our code specifies the document type with doctyp HTML, indicating to the browser that this is an HTML5 document. We then open the HTML tag to define the beginning of our HTML document, setting the language to English with the lang attribute. Inside the head section, we include essential meta tags that help characterize our document. The meta charset equals UTF-8 tag ensures that the browser interprets the character encoding correctly, while the meta name equals viewport content equals width equals device width, initial scale equals 1, 0. Tag makes the web page responsive, adjusting the layout for different screen sizes. The title tag allows us to specify the web page title, which will appear in the browser tab. Moving to the body, this is where the content visible to users resides. we implement the main heading using the h1 tag, welcoming users to our website, followed by a p tag containing a simple paragraph. This structure forms the foundation of our web page, illustrating how HTML allows us to organize content effectively. Now we will implement some CSS to enhance the visual appearance of our web page. CSS allows us to add styles and improve the layout defined by our HTML structure. In this example, we begin by setting the background color of the entire body to a light gray. This is done by selecting the body element in our CSS, creating a soft and neutral backdrop that helps the content stand out. Next, we specify styles for the main heading, the h1 element. Here, we set the text color to blue, which not only adds a vibrant touch but also improves readability against the gray background. Additionally, we select a font family, Arial, sans serif, to give the heading a modern, clean aesthetic. Finally, we enhance the paragraph text by adjusting its font size to 16 pixels and setting a line height of 1.5. This adjustment helps make the text more legible and user-friendly, creating sufficient spacing between lines for easier reading. Together, these CSS rules exemplify how styling separates design from structure, allowing us to create visually appealing and user-friendly web pages. Now let's implement a simple interactive feature using JavaScript. In this example, we start by adding a button element to our HTML, which users can click to trigger an action. The button has an ID of alert button, allowing us to easily reference it in our JavaScript code. Next, we use JavaScript to add interactivity by specifying what happens when the button is clicked. We achieve this by using the addEventListener method, which listens for a click event on the button. When the button is clicked, a function is executed that calls the alert method. This method displays a pop-up alert box with a message saying, "Hello, this is an alert box." This simple interaction demonstrates the basics of how JavaScript can enhance user engagement on a web page. By understanding this example, you gain foundational insight into how JavaScript can respond to user actions, paving the way for more complex functionalities in your web applications. This principle of event handling is crucial for all dynamic behavior you will encounter as you delve deeper into web development. Now let's take a look at a simple React component that showcases the fundamentals of functional components. In this code, we start by importing React, which is necessary for creating elements we can render. We define a functional component named greeting using an arrow function. This component effectively encapsulates our UI logic and styling by returning a single React element, an h1 header that displays a welcoming message. The beauty of using a functional component like this lies in its simplicity and reusability. You can invoke this component anywhere in your application, making it easy to maintain and organize your code. Additionally, leveraging arrow functions streamlines the function declaration process, allowing for concise syntax. Moreover, this structure provides a great foundation for building more complex components in React. By managing the state and props effectively, you can create an interactive user experience. As we explore more about React, you'll see how components like greeting serve as building blocks for developing dynamic web applications. Now let's explore how block scope works with the let and const keywords in JavaScript. Inside the curly braces, we define two variables, one using let and the other using const. The variable block scoped is declared with let, allowing it to be modified within its block. Similarly, also block scope declared with const cannot be reassigned. However, once we move outside of the defined block, both variables become inaccessible. This design helps prevent unintended variable clashes in larger applications, promoting cleaner and more maintainable code. To illustrate this, if we attempt to log either block scoped or also block scoped to the console outside of the block, we will encounter a reference error, indicating that these variables do not exist in that scope. With this understanding, you can see how let and const enhance the way we manage variable visibility in our code, ultimately leading to fewer bugs and more structured applications as we build complex systems, such as those in React. Next, we will write an example using template literals, a feature that simplifies string creation in JavaScript. In our code, we begin by declaring a variable name, which is assigned the string value John. This variable will be used to demonstrate how easy it is to incorporate variables directly into strings using template literals. Now let's implement a greeting message. We create another variable called greeting, which is set to a template literal, a string that is enclosed in backticks. Inside this string, we embed the name variable using the $sign and curly braces syntax, name. This allows us to dynamically insert the value of name into the string. When we log the greeting variable to the console, the output reads, "Hello, John, welcome to our website." This method of string interpolation enhances readability and maintainability of your code, particularly in scenarios where you want to build complex or dynamic strings, an everyday task when developing React applications. Instead of using cumbersome string concatenation, template literals provide a more streamlined approach to creating engaging user interfaces. Now let's take a look at how we can leverage arrow functions for cleaner and more concise code. In the example provided, we've defined a function called add that takes two parameters, a and b. Instead of using the traditional function keyword, we use the arrow function syntax, represented by the equals operator. This allows us to write the function in a single line where the expression a plus b is implicitly returned without needing an explicit return statement. This simplicity enhances readability, making it easier to understand at a glance. Following the function declaration, we demonstrate its use by calling console log add 5, 3. This execution passes the values 5 and 3 to our add function, which computes their sum and logs the output to the console. In this case, the output will be 8. The use of arrow functions is particularly advantageous in modern JavaScript, especially in frameworks like React, where writing concise and readable code is paramount for managing complex user interfaces efficiently. Now let's take a look at how destructuring works in JavaScript. In the code, we begin by defining a user object that contains two properties, name and age. Instead of accessing these properties individually using dot notation, we can use destructuring to directly unpack the values into separate variables. This is achieved by declaring the variables name and age within curly braces, which corresponds to the properties of the user object. As a result, name is assigned the value Alice, and age is assigned the number 25 without the need for repetitive syntax. This not only streamlines our code, but also enhances readability and maintainability. Finally, we log the values of name and age to the console, which outputs Alice and 25 respectively. By utilizing destructuring, we simplify the code, making it shorter and clearer, which is especially beneficial in a React context when managing props and state. Overall, destructuring enables us to write cleaner code while still effectively accessing the data we need. Now let's take a look at how we can utilize the spread and rest operators in JavaScript. The spread operator allows us to expand an array into individual elements, which is particularly useful when we want to create a new array that contains elements from multiple sources. In our example, we start with an array of numbers, and by using the spread operator, we can easily merge it with another array. This demonstrates how we can dynamically combine arrays, making our code more modular and flexible. On the other hand, the rest operator serves a different purpose. It allows us to capture multiple arguments passed to a function into a single array. This means that we can create functions that accept a variable number of arguments without knowing beforehand how many there will be. In our code, we define a function that uses the rest operator to gather all arguments and sums them up using the reduce method. This is an essential technique for creating reusable functions that can adapt to varying inputs, enhancing the versatility and maintainability of our code. In summary, web development starts with mastering HTML, CSS, and JavaScript, each serving a unique purpose. As applications grow in complexity, frameworks like React simplify the process, allowing developers to create reusable components. By leveraging modern JavaScript features including let_const, template literals, arrow functions, destructuring, and rest spread operators, we can write more efficient and maintainable code. As we continue our journey into React and the exciting world of front-end development, these concepts will not only be useful but essential to your success as a web developer. JavaScript has undergone many transformations over the years, with ES6 being a landmark version that introduced a variety of features designed to make coding easier and more efficient. In this lesson, we delve into modern JavaScript features that play a crucial role in React.Js development. So far, we learned about web development revolving around three key technologies: HTML for structuring content, CSS for styling it, and JavaScript for adding functionality. We discussed the importance of modern JavaScript features, such as let_const, template literals, and destructuring, which enhance code clarity and efficiency. Additionally, we recognized the role of frameworks like React.Js in simplifying the development of complex user interfaces through reusable components. In this session, we will cover some more advanced modern JavaScript features like arrow functions, spread rest operators, and async await, and see how they integrate with React to create better applications. Now let's take a look at a common use case for arrow functions within a React component. Here, we define a greeting component that takes in a name, prop, and returns a simple heading element. The use of an arrow function not only streamlines the syntax, but also ensures that the this context is correctly bound to the surrounding scope, which is particularly useful in class components or when passing callbacks. Next, we can see how this would look if we opted for a traditional function declaration. The structure remains the same, greeting receives the props and renders the heading, but you'll notice that the traditional function syntax is a bit more verbose. While both implementations ultimately fulfill the same purpose, using an arrow function enhances readability and reduces boilerplate, making your code cleaner, especially in larger applications. This efficiency in using arrow functions is an essential part of modern JavaScript practices, contributing to more intuitive and maintainable code development in React. Next, we will see how template literals enhance our ability to create dynamic strings in JavaScript, particularly useful in React applications. Now, let's implement a basic example where we create a welcoming message for a user. We define a constant name with the string value Alice. By using backticks, we can create the variable message, which allows us to neatly embed the name variable within a larger string. This eliminates the need for cumbersome concatenation and results in a more readable output. Now let's take a look at how we can utilize template literals in a React component. We'll define a functional component called userProfile, which receives user data via its props. Inside this component, we create a variable named welcome message that combines static text with the user's first and last name using template literals. This message is then rendered dynamically within an H2 element. This approach not only enhances the clarity of our code, but also ensures that the final output is well organized and easy to read, making our presentation of user data much more effective. Now let's explore how we can effectively use destructuring in a React functional component to enhance code clarity. In the first example, we define a userProfile component that accepts props as an argument. We then utilize destructuring to extract specific properties, user name and user age, straight from the props object. This approach allows us to reference these properties directly within our component's return statement, simplifying our code and improving its readability. Next, we can take it a step further by destructuring right in the function parameters. In this revised version, we create the same userProfile component, but instead of first accepting props and then extracting the values, we destructure the username and userAge properties directly in the component's signature. This not only reduces the amount of code we write, but also immediately makes clear what data our component relies on, enhancing maintainability and minimizing confusion for anyone reading the code. By adopting destructuring, we adhere to best practices in modern JavaScript, making our code cleaner and more efficient. Now let's implement some code using the spread operator to manage state in a React component. Here we have a user state object initialized with the name Alice and age 25. To update the user's age efficiently, we define the updateUserAge function, which takes newAge as a parameter. Inside this function, we use the setUser function to update the state. By passing a function to setUser, we gain access to the previous state, prevUser. We create a new user object using the spread operator, which allows us to copy the previous state properties while updating just the age with the new age value. This approach respects React's principle of immutability, ensuring that we do not directly mutate the state. Next, we will write a userProfile component that demonstrates the use of the REST operator. In this component, we destructure the name and age from the props, while the REST operator gathers any additional properties into other props. This allows us to pass extra props seamlessly to a child component, other component, which can enhance modularity and reduce redundancy. By thoughtfully managing props this way, we make our components more flexible and adaptable, fostering better collaboration across our code base. Now let's see how we can implement async await in a React component to effectively fetch user data. In this example, we define a functional component called userProfile that uses the useState hook to manage the user state. Initially, the user state is set to null, indicating that no user data is available yet. Next, we utilize the useEffect hook to perform side effects, which is perfect for fetching data when the component mounts. Inside useEffect, we define an asynchronous function named fetchUser. This function is where the magic happens. It waits for the fetch request to complete by using the await keyword, ensuring that our code pauses until the promise is resolved. This creates a clean flow for processing the response data, which we then convert to JSON format. Once we have the data, we update the user state with the fetched information using the setUser function. If any error occurs during the fetching process, we catch it and log an error message to the console. Finally, we conditionally render either the user's name or a loading message, providing a user-friendly experience while the data is being fetched. Now let's see how we can implement modularity in our React application. We begin by creating a separate file named Greeting.Js, which exports a functional component that displays a greeting message. This component takes a prop called name and renders it within an h1 heading. By modularizing code into its own file, we enhance maintainability and readability, allowing us to focus on distinct functionalities separately. Next, we will use this greeting component within our main application file, app.js. In this file, we import the greeting component, demonstrating how to utilize the import statement to bring in functionality from another module. In the app component, we render the greeting component and pass it a prop with the value Alice. This encapsulation not only keeps our components organized, but also adheres to the principle of single responsibility, making it easier to manage and modify each part of our application as it grows. Ultimately, this structure fosters collaboration and simplifies the debugging process when changes are necessary, ensuring that each module can be developed and tested independently. In summary, modern JavaScript features fundamentally enhance how we write and manage our code in React. The arrow function simplifies our component syntax while preserving context, and template literals improve string management significantly. Destructuring helps us handle props more intuitively, and the spread rest operators allow us to manipulate data structures effectively. By incorporating async await for seamless asynchronous behavior and modules for organization, we are not only crafting better React applications, but also improving our overall coding practice. As you continue to explore React, embrace these features and integrate them into your workflow for a smoother development experience. Keep experimenting and happy. Welcome to our exciting journey into the world of fundamental web development concepts. Today, we'll break down the core elements that make up the backbone of the web: HTML, CSS, and JavaScript. So far, we have covered essential modern JavaScript features that dramatically enhance our coding efficiency, especially in React.Js. We explored arrow functions, template literals, destructuring, spread rest operators, and the async await pattern, which makes working with asynchronous operations a breeze. Now, we're diving into the foundational concepts of web development that will empower you to understand and build your own web applications. Next, we'll write a simple HTML structure for our web page. This code begins with the doctyp HTML declaration, which informs the browser that we're using HTML5. The HTML tag wraps everything to indicate that the content is an HTML document, and we also set the language attribute to English, lang equals n, which helps with accessibility and search engine optimization. Inside the head section, we define important metadata. The meta charset equals UTF-8 tag ensures that the document is interpreted using the UTF-8 character encoding, supporting a wide range of characters and symbols. The meta name equals viewport content equals width equals device width, initial scale equals 1, 0. Tag is crucial for responsive design, allowing our web page to scale properly on different devices. The title tag sets the title of the web page, which appears on the browser tab. In the body, we include a main heading using the h1 tag that conveys a welcome message to visitors. Below the heading, we add a p tag containing a simple paragraph that demonstrates how HTML operates. This structured layout showcases the essential components of a web page, making it clear and easy to understand for anyone learning web development. Now let's see how we can enhance our simple web page using CSS. In this snippet, we begin by defining styling rules specifically for the body element. We set the font family to Arial, a widely used sans serif typeface, which ensures that our text is clean and readable. Next, we apply a light gray background color, creating a soft and inviting atmosphere for our content. We also establish zero margins and provide padding of 20 pixels. This ensures that our content does not stick to the edges of the browser window, giving it a more polished and spacious look. Moving on, we customize the heading element, H1, giving it a darker gray color to draw attention and establish a contrast against the background. Additionally, for the P elements, we set the font size to 18 pixels, which provides better readability, and a lighter gray color to maintain visual harmony without overwhelming the viewer. These styles together help create a cohesive and visually appealing layout, making the page more engaging and user-friendly. Now let's implement a simple interactive feature using JavaScript that enhances user engagement on our web page. We will create a button that, when clicked, will display an alert message to the user. In this example, we start with a button element defined by the button tag. The key attribute here is onClick, which listens for click events and triggers the JavaScript function showAlert whenever the button is clicked. This setup is crucial as it connects our HTML to the JavaScript functionality, allowing for interaction based on user actions. Next, we define the showAlert function within a script tag. This function's sole purpose is to invoke the alert method of the browser, displaying a message to the user. When executed, the alert will show the text "Hello." You click the button, providing immediate feedback that the button press was recognized. This simple interaction illustrates how JavaScript seamlessly integrates with HTML to create a dynamic user experience, paving the way for more complex functionalities as we progress in our web development journey. Now let's discuss the difference between front-end and back-end development. The front-end encompasses everything that users interact with directly in their web browser: the layout, design, and user interface. On the other hand, the backend involves the server side of the application where data processing happens, managing databases, application logic, and server configuration. If a web application was a car, the front end would be the shiny exterior that turns heads, while the backend would be the powerful engine under the hood that keeps everything running smoothly. To illustrate this, imagine a YouTube homepage. The grid of video thumbnails you see is the front end. Each time you refresh the page, a different set of videos appears, which is dictated by the backend. The backend retrieves data from databases and sends it to the front end to display content appropriately. Now let's see how we can implement a simple React component to display a greeting message. In our code, we start by importing React from the React library, which is essential for building the component, as it allows us to leverage React's capabilities to create interactive user interfaces. Next, we define a functional component named greeting. Functional components are simpler and often preferred for their ease of readability and performance. Inside this component, we return a single JSX element, a heading that displays the message, "Hello, welcome to my React application." This showcases how easily we can write declarative code that describes what our UI should look like. Finally, we export the greeting component so that it can be used in other parts of our application. This modular approach promotes reusability, enabling us to incorporate this component wherever needed without redundancy. Through this simple example, we can observe the foundational concepts of React, emphasizing component-based architecture and the use of JSX for defining elements in a user-friendly manner. As we make our way through the development landscape, we often encounter architecture designs like the three-tier web architecture. This architectural pattern divides an application into three layers: the presentation layer, the application layer, and the data layer. The presentation layer is what users interact with the front end. The application layer handles the business logic and data processing, backend. And lastly, the data layer encompasses the database where all your information is stored. This separation of concerns helps in creating scalable and maintainable applications where each layer can evolve independently. Imagine trying to revamp a car. If all the components were tightly coupled, replacing the engine might also mean redoing the dashboard. A clear separation helps keep each component focused and adaptable to change. To wrap up our discussion, it's essential to understand that the core technologies behind web development, HTML, CSS, and JavaScript, are powerful on their own, but together they formulate the backbone of every interactive web application. Learning how they interact and complement each other will pave the way for you to become a proficient web developer. So far, we have delved into the critical concepts of web development, including understanding the roles of HTML, CSS, and JavaScript, the differences between front-end and back-end development, the benefits of using frameworks like React.Js, and the significance of architectural patterns such as the three-tier architecture. Now that we've built our foundation, we are all set to explore these technologies in detail while creating fantastically dynamic web applications. Keep your coding spirit alive and don't forget to experiment. You never know what masterpiece you might create. Let's dive into the modern features of JavaScript, specifically how they enhance our React.Js applications. JavaScript has had many versions over the years, and ES6 is one of the prominent versions that introduced a slew of powerful new features. These features are essential for writing cleaner, more efficient, and more maintainable code, especially in the context of React.Js. So far, we learned about the fundamental web development concepts, including HTML, CSS, and JavaScript, which serve as the backbone for creating interactive web applications. We explored how HTML structures a web page, CSS enhances its style, and JavaScript adds interactivity. Additionally, we discuss the distinction between front-end and back-end development, the role of frameworks like React.Js, and the significance of architectural patterns like the three-tier architecture. This foundation prepares us to dive deeper into these technologies as we continue our journey in web development. Now let's take a look at how we can implement a simple React component that manages state and utilizes arrow functions. In this code, we define a class called myComponent that extends React component. The constructor initializes the component state with a count property set to 0, which keeps track of the number of times a button is clicked. Next, we define the increment count method using an arrow function, which is a modern JavaScript feature that allows us to avoid explicitly binding the context of this in the constructor. This means that this seamlessly refers to the component instance, making our code cleaner and easier to read. When the button in the render method is clicked, it triggers the increment count function, which updates the state by incrementing the count value. Finally, the render method returns the JSX displaying the current count and a button that, when clicked, increments the count. This concise implementation exemplifies how modern JavaScript features enhance React development, making our components more straightforward and manageable. Now let's see how we can implement template literals in our React component to enhance string interpolation. In the code, we define a greeting component that uses React's render method to display a personalized message. Within this method, we declare a constant name set to John, which serves as the variable we want to include in our greeting. Notice how we utilize backticks to create a template literal. This allows us to easily embed the name variable directly inside the string by using name. The advantage of using template literals over traditional string concatenation is twofold. It improves the readability of our code and significantly reduces the chances of errors associated with syntax issues that can arise from concatenating strings with operators like plus. When the component is rendered, the output is a dynamic greeting message. Hello, John, welcome to our site. Using template literals in this way is especially useful in JSX, where we may want to include dynamic content seamlessly within our markup. This feature not only makes our code cleaner, but also aligns with modern JavaScript practices, promoting better maintainability in our applications. Now let's take a look at how we can utilize destructuring to handle props in a functional component. In the user profile component, we directly destructure the name and age properties from the incoming props within the function parameter. This approach not only streamlines our code by eliminating the need to repeatedly reference the props object, but it also enhances readability, allowing us to focus on the actual data being used. Within the component, we return a simple JSX structure that displays the user's name and age. By directly inserting these variables in curly braces, we can seamlessly embed JavaScript expressions within our HTML-like syntax. This method of handling props not only simplifies the structure of our component, but also makes it easier to pass different props without cluttering our code with additional references. Overall, embracing destructuring in our React components leads to cleaner, more maintainable code, facilitating a better experience as we develop our applications. Now let's take a look at how we can efficiently manage props in React using the spread operator. In the example, we define a parent component that accepts any number of props and passes them down to the child component without needing to list each prop explicitly. This is particularly useful in complex component hierarchies, where you may have numerous properties to manage. By using props, we can ensure that all received props are seamlessly spread into the child component, making the code more concise and clean. Next, we will write the following function that showcases the REST operator. This operator is designed to streamline the handling of function parameters. In our example, we define a sum function that utilizes the REST operator to accept an arbitrary number of arguments. The function then sums these values using the reduce method, thus demonstrating how you can gather a potentially unknown number of inputs into a single array and process them effectively. This flexibility is beneficial, especially when dealing with dynamic data, such as form inputs, allowing us to easily manage and sum multiple values. Now let's take a look at how we can effectively fetch and display data in a React component using the async await syntax. The dataFetcher class component initializes its state with data set to null and loading set to true, indicating that data is being fetched. Inside the component didMount lifecycle method, we utilize the async keyword, which allows us to write synchronous code that looks synchronous. Here we use the await keyword to pause execution until the fetch request is completed, enabling us to retrieve and parse the JSON response seamlessly. If the data fetch is successful, we update the component state to reflect the fetched data and set loading to false. However, in the event of an error during the fetch process, we catch the error using a try-catch block, logging the error to the console and ensuring that the loading state is updated appropriately. Finally, during rendering, we check the loading state. If it's still true, we display a loading message, and once the data is available, we render it in a readable format. This implementation not only enhances code readability, but also demonstrates a clean approach to error handling, showcasing the power of modern JavaScript features in React applications. Now let's see how we can manage asynchronous operations in our React component using the Promise API. In this code, we define a class called userFetcher, which extends React's component. The component maintains a state with two properties, user and error. Initially, both are set to null. When the component mounts, the component.didMount lifecycle method is invoked, initiating an API fetch request to retrieve user data from a specified endpoint. Using promises, we handle the response by chaining then calls. The first then processes the response to extract the user data in JSON format, and the second then updates the state with the retrieved user information. In case the fetch operation encounters an error, the catch method captures it and updates the state with an appropriate error message. This structured approach not only ensures effective error handling but also enhances the readability of the code. In the render method, we check for any errors and conditionally display the error message. If there are no errors, we show the user's name or loading message, providing a seamless user experience. Now that we've covered some modern features, it's crucial to highlight the benefits they bring to our code bases. These features not only reduce boilerplate code, improving productivity, but they also promote readability and maintainability, which are vital in collaborative environments like those often found in React development. Using modern JavaScript features effectively can drastically enhance your development workflow, making your applications not just functional, but also elegant and robust. Embracing these features allows you to write code that is more intuitive and aligned with contemporary JavaScript practices. To summarize, we explored several key features introduced in ES6 that significantly boost our productivity and code quality in React applications. Arrow functions, template literals, destructuring, the spread and rest operators, async await, and promises. Each of these features aids not just in simplifying syntax, but also in making our code more readable and maintainable. As you continue your journey into React and JavaScript, remember to embrace these modern features. They'll not only help you write cleaner code, but will also make your development process more enjoyable. So go ahead and implement these features in your next project. Your future self will thank you. Happy. In this video, we will dive into the fascinating world of web development. We'll explore the foundational concepts that form the backbone of any website you visit today. So far, we have learned about the modern features of JavaScript, particularly how they enhance our React.Js applications. We delved into key ES6 features such as arrow functions, template literals, destructuring, the spread and rest operators, async await, and promises, all aimed at improving code readability and maintainability. This understanding has laid a solid groundwork for your web development journey as we now transition into broader web concepts. Let's start with the very basics. What is web development? In simple terms, web development is the process of creating websites and web applications. This process can be divided into two primary areas, front-end development and back-end development. Think of the front end as everything that the user interacts with directly in their web browser. This is your visual landscape. Meanwhile, the back end handles the server, application, and database, making sure everything on the front end works correctly. For instance, consider a dynamic platform like YouTube. When you open up a YouTube page, you're greeted with a vibrant interface showcasing videos. This interface, which includes everything from thumbnails to buttons, is front-end development at work. Behind the scenes, however, the decisions on which videos to show you, based on algorithms, your viewing history, and more, are managed by back-end systems. It's the intricate dance between the two that makes modern web applications functional and enjoyable for one sauce. Now let's see how we can structure a basic HTML document to lay the foundation for our web page. We begin with the declaration, doctyp HTML, that informs the browser we're using HTML5. The HTML lang equals n tag encapsulates our entire document and specifies the primary language as English. Inside the head, we include meta tags for character set and viewport settings, ensuring our web page displays correctly on different devices. Adding a title provides a name for our tab in the browser. Next, we transition to the body, where the visual elements reside. Here we create a welcoming heading using h1 and provide introductory content through a paragraph tag p, which gives context about web development. Lastly, we incorporate an anchor tag to create a hyperlink, allowing users to visit another site or resource. All these elements collectively help form a structured, interactive experience for users, showcasing the essential components of a well-defined web page. This foundational knowledge is crucial as we continue exploring more complex styling and interactivity concepts. Next, we will write the following CSS styles to enhance the visual elements of our web page. In this CSS code, we define the styles for the body, heading tags, and links. For the body, we set the font family to Arial, which is a clean and modern sans serif font, providing a readable text. The background color is set to a light gray tone, creating a pleasing contrast with the text color, which is a darker shade. This choice ensures that the content is easy to read. Now let's take a look at how we apply styles to our headings. In this code, we target the primary heading, or h1 tag, and specify that its text color should be a vibrant green. This not only makes the heading stand out, but also gives it a fresh and lively appearance, inviting users' attention. Finally, we also customize the appearance of links by removing the default underline and changing their color to a striking blue. This enhances usability while maintaining clean aesthetics. Overall, this separation of structure and style allows us to maintain and update our web page's design without interfering with the content itself, fostering a clear and organized codebase. Now let's implement a simple interactive button using JavaScript to demonstrate how we can enhance user engagement on our web pages. We begin by creating a button element with the text "Click Me" and a paragraph that displays "Hello." This sets the stage for our interaction. Users will click the button to see a change. Next, we use JavaScript to add functionality to our button. By selecting the button element through its ID with document getElementById button, we can attach an event listener. This listener is set to respond to click events. When the button is clicked, a function is triggered which accesses the paragraph element through document getElementById text. Inside the function, we update the paragraph's content from hello to you click the button by changing its inner HTML. This dynamic response illustrates JavaScript's ability to handle user actions in real time and modify the content displayed on the web page. By using event handling effectively, we enhance the interactivity of our web applications, making the user experience more engaging and lively. Now let's see how we can implement a simple React component that renders a header. This code begins by importing the React library, which is essential for developing components in a React application. Next, we define a functional component called header. Functional components are one of the fundamental ways to build React components using JavaScript functions. Inside the header component, we utilize a return statement to specify what our component will render. In this case, it returns an HTML heading element, h1, containing the text, "Welcome to my React app." The use of JSX syntax allows us to write HTML-like code within our JavaScript, which React then transforms into actual HTML elements for the browser. Finally, we export the header component, making it accessible for use in other parts of our application. By encapsulating our header logic within this component, we make it reusable, promoting a modular and maintainable code structure. This approach aligns perfectly with the overall principles of web development and React's philosophy of building user interfaces through component composition. Before moving forward, let's recap briefly. So far, we have covered what web development entails, the importance of HTML, CSS, and JavaScript, and introduced frameworks like React that facilitate building complex applications efficiently. Now we will transition to understanding the architecture of web applications, particularly breaking down the three-tier web application architecture. This model separates the application into three distinct layers: presentation, application logic, and database. In the presentation layer, users interact with the user interface. The application logic layer handles the business logic and user input, processing it correctly. Lastly, the database layer stores and retrieves data to ensure a seamless experience for the user. Each layer communicates with one another to deliver a cohesive application for success. Now let's see how we can define a simple function to add two numbers using the modern arrow function syntax introduced in ES6. The first part of the code declares a constant variable named addNumbers, which holds an arrow function that takes two parameters, A and B. This function returns the sum of these two parameters in a concise manner, allowing us to write less code while maintaining clarity. Next, we call the addNumbers function and pass two numerical arguments, 5 and 10. The function executes, adding these two numbers together, and the result, 15, is then logged to the console. This demonstrates how arrow functions not only streamline the process of writing functions, but also enhance the readability of the code. Moreover, the ability to write functions in a single line like this encourages cleaner coding practices, which is particularly beneficial when managing larger code bases. Embracing such modern syntax can significantly improve your efficiency in JavaScript development. In conclusion, web development is a multifaceted discipline that combines design and engineering to bring interactive, dynamic websites to life. The essential skills you need to master include an understanding of HTML, CSS, and JavaScript, as well as familiarity with frameworks and libraries that aid in development. Moving forward, you will continue to refine these skills, leveraging modern JavaScript tools and concepts to create engaging web applications. Thank you for joining me tonight, and I look forward to exploring the next set of topics with you, which will further enhance your web development practice. JavaScript has had many versions over the years, and ES6 is one of the JavaScript versions, introducing a set of powerful features that enable developers to write cleaner, more efficient, and more maintainable code. In this lesson, we're going to unlock the full potential of modern JavaScript, especially in the context of React.Js. We'll explore how these new features can streamline our development process and improve our overall coding experience. So far, we have learned about the foundational concepts of web development, focusing on the importance of HTML, CSS, and JavaScript. We explored how these technologies work together to build interactive web applications, with an introduction to frameworks like React that streamline development. Additionally, we touched on modern JavaScript features that improve code efficiency and readability. Moving forward, we will delve deeper into specific ES6 features and how they can enhance our React.Js applications. Now let's see how we can define a basic multiplication function using both traditional and modern syntax. First, the traditional way of creating a multiplication function involves using the function keyword. This method explicitly names the function and requires the use of the return statement to output the product of two numbers, a and b. Next, we will write this same function using ES6's arrow function syntax. By defining the function as a constant and using the arrow equals operator, we streamline the syntax, making it shorter while still achieving the same functionality. Arrow functions also allow us to implicitly return a value when the function consists of a single expression, eliminating the need for curly braces and return keywords. Now let's take a look at how to implement an event handler in a React component using arrow functions. We define a functional component called app, which features a method handleClick that will log a message to the console when invoked. The handleClick method is created as an arrow function, allowing us to maintain the correct this context effortlessly, especially important in React's dynamic environment. This clarity and conciseness are what make arrow functions a preferred choice in modern JavaScript development. Next, we will explore how to utilize template literals for creating dynamic and readable strings in our applications. Let's start by looking at a traditional method of combining strings, where we define a name and concatenate it with another string using the plus operator. This approach can become unwieldy, especially when constructing long strings or integrating variables within them. Now let's see how we can implement template literals instead. By using backticks, we can easily include variables within our strings without cluttering the code with multiple concatenation operators. This method also supports multi-line strings, allowing for greater flexibility in formatting the output. For instance, we can create a message that greets a user by name and spans multiple lines seamlessly. In a React component, we can utilize template literals to render dynamic content more clearly. Using the same interpolation technique, we can display personalized greetings directly within our JSX. This not only enhances readability, but also minimizes the risk of errors that often occur with traditional string concatenation, making our code cleaner and more maintainable as we integrate it into larger applications. Next, we will write a simple object and demonstrate how to use destructuring to extract values from it. Here, we create a user object containing properties such as first name, last name, and age. Instead of accessing these values through the object one by one, we utilize destructuring to extract first name and last name in a concise manner. This allows us to easily log these values to the console, outputting Jane Doe. Now let's see how we can implement this approach in a React component. We will define a functional component called userProfile that receives these properties as parameters through destructuring. By doing this, the component becomes cleaner and more organized. There's no need to refer to props first name or props last name. Instead, we can directly use first name, last name, and age within our JSX. This not only enhances readability, but also makes it immediately clear which props our component is utilizing, thereby streamlining the development process. Now let's take a look at how we can effectively utilize the spread operator in JavaScript. The spread operator, represented by 3 dots, allows us to expand an iterable, such as an array, into its individual elements. In our example, we have 2 arrays, array1 and array2. By using the spread operator, we can easily merge these 2 arrays into a single array called combined. The resulting array includes all elements from both arrays, showcasing the operator's ability to combine datasets seamlessly. This feature is particularly valuable when working with state management in React, as it simplifies the process of merging state changes while retaining existing properties. Next, we will explore the REST operator, which is also denoted by 3 dots but serves a different purpose. The REST operator allows us to gather multiple function arguments into a single array. In our code, we define a function called sum that uses the REST operator to accept a variable number of arguments, collecting them into an array called numbers. This flexibility enables us to calculate the total sum of these numbers dynamically. The use of the REST operator makes it easy to create functions that can handle varying inputs, promoting more adaptable and reusable code. Now let's implement the following example to illustrate how we can work with promises and the fetch API to handle asynchronous operations. First, we have a typical promise-based approach for making an API call to retrieve data from a remote server. In this case, we use the fetch function to initiate the request. After fetching the data, we handle the response by chaining then methods. The first then passes the response as JSON, and the second then logs the resulting data to the console. However, this method can become cumbersome and lead to callback hell, especially with more complex logic. Next, we will write a cleaner version using the async await syntax, which makes asynchronous code look more straightforward. By defining an asynchronous function named fetchData, we can use the await keyword to pause execution until the promise from the fetch call resolves. This allows us to obtain the response directly, and we subsequently parse it into JSON format. Should any error occur at any point in this process, we catch it in a try-catch block and output an error message. This approach not only simplifies the code structure, but also significantly enhances readability and maintainability, particularly important when working on larger React applications. Now let's implement a simple Math.js module to demonstrate how we can organize our code into reusable components. In this module, we define 2 functions, add and subtract. The add function takes 2 parameters, a and b, and returns their sum in a concise arrow function syntax. Similarly, the subtract function performs a subtraction of b from a. By using the export keyword, we ensure these functions can be easily imported into other files, promoting code reuse. Next, we'll see how we can utilize this module in another file. By importing our add and subtract functions from Math.js, we can call these functions to perform calculations. For instance, using console log, we can display the results of adding and subtracting 2 numbers. This modular approach not only enhances code organization, but also allows for easier maintenance and scaling of our applications, especially in complex React projects where components may be spread across multiple files. Leveraging modules in this way promotes clean code separation, making the development process smoother and more efficient. In React, leveraging modern JavaScript features not only boosts our code efficiency, but also enhances the overall development experience. As you've seen, concepts like arrow functions, template literals, destructuring, and promises open up a world of possibilities for building robust applications. As we have just scratched the surface of modern JavaScript, remember that these features are designed to simplify our coding practices while delivering powerful capabilities. Becoming familiar with these tools will empower you in both your React development journey and any JavaScript projects you undertake in the future. In conclusion, modern JavaScript isn't just about writing code. It's about writing code that is clean, manageable, and easier to read. As we wrap up this session, remember that mastering these features and your understanding of their applications in React.Js will significantly elevate your coding skills and enhance the performance of your applications. Keep practicing, and soon enough, these concepts will become second nature to your development style. In this final section, we will do a project challenge to apply what we have learned so far. Your task is to build a personal project management web application using React. which will allow users to create, read, update, and delete projects, as well as manage tasks within each project and track their progress. You will set up a new React application, implement routing with React Router, use Axios for API integration, and style your application using CSS Modules or styled components. You can include user authentication as an optional feature and create a dashboard that displays all projects alongside forms for project creation and task management. Remember, this is your opportunity to showcase everything you've learned throughout the course by tackling this real-world application. You can find all the details for the final project in the GitHub repository linked in the description. Good luck and happy